Okay, so from there we get what is called recurrent neural network. So in recurrent neural network, it's just we have a function. In that function, we provide the input as our text, and also in that function, we have to provide like a past memory of the previous neuron. What was the previous neuron learn about the text you give it? So we take that memory, we apply it, or we add it into the next neuron. So that past memory, we call it H here. So it is the H, but the H of previous time. That's why we say T minus 1, previous time. Yeah, so that is recurrent neural network. Okay. So as I have said that in recurrent neural network, we just want to apply that recurrence so that our neuron or our neural network might have some memory. Yeah, so okay, that memory or that H that we saw previously here is called the state of H. We can call it a state of H. Okay, as I have said, that state of H is the past memory. So what are design criteria that we want to consider when we are creating or we are modeling RNN? Okay, the first design criteria is that we want our RNN to be able to handle the different text with different length. So if you give it one sentence, or you give it a paragraph, or you give it one page, it has to be able to handle it. Also, it must have long-term dependence. Long-term dependency is simply you can say it must have some memory. It must remember what was the previous text about, so that it can predict what is the next text depending on what was previous said. Also, it must maintain some orders, because there are some sentence, if you change order of the sentence, you completely change what was intended to be meant. So also it has to have ability to share parameters. Okay. By sharing parameter is how memory acquired. So so recurrent neural network must meet all those 4 criteria. Now let's see some problem that we might face when we use RNN in trying to predict the next token. So let's say I have this sentence. The sentence say the best AI conference I know today in Tanzania is Emai Conference. Now, here what I want is to predict this last words Emai Conference. So I want to be able to enter in my RNN model the text, the best AI conference I know today in Tanzania is. So I want my model to predict that Emai conference. So the first problem that we face in RNN is that RNN does not understand the words. So if we try to take that sentence and put as it is to RNN, it will not understand it. So what actually RNN understand in neural network is numbers. So what we have to do, the first, is to convert these words into numbers. So the first problem that you will face with RNN or neural network in general is that it does not take image, text, or audio. You have to convert all those data into numbers. Yeah, so let's try to understand what are the process of converting this text into numbers. So first of all, you have to collect some vocabulary. Yeah, so here you have to have some knowledge of about the language you are using. For example, Swahili is different from English, and Swahili have different vocabulary from English. So you have to collect all the vocabulary and put it in corpus of data. So then what you want to do, what you have to do is to try to arrange them and try to give each vocabulary a number. For example, here you can see a cat is 1, a is 1, cat is 2, and okay. So after that, you take each number and convert it into binary. Okay. For example, 1 in binary is 1 0 0 0 0 0 0. 2 in binary is 0 1 0 0 0 and so by doing that, we have already creating some embeddings. Okay, so the binary representation of the words is embedding. We use the term embedding. So the next problem that RNN facing is called the exploding gradient. Here it's like you want to prepare yourself for an exam and you study too much that when you go when the exam starts you don't remember anything. Okay? Mfano, ngoja niongee kwa Kiswahili. Mfano mzuri sana. Kadri nasoma chuo kama Jumatatu kuna mtihani unaitwa DC wa umeme. Weekend nikakesha nasoma, alafu baadaye nikaangalia movie na muziki. Kwa hiyo nilipofika kwa mtihani nilichoweza kuandika ni data given tu kwenye mtihani. Mtihani ulikuwa na maswali mawili, dakika 30. Kwa hiyo nilichoweza kuandika ni data given tu, kaandika data given. Hapo kichwani wimbo wa Diamond unaimba na mkumbuka na Michael Scofield. Kwa hiyo hapo unaweza ukasema hapo kilichotokea hapo ni gradient zili explode. Study too much mpaka weight zinakuwa na namba kubwa, kwa hiyo zinashindwa ku extract important information. So one way ya kusolve gradient exploding by doing gradient creeping. Kwa hiyo sometimes what they do is to try to minimize the numbers from gradient or from weight. Okay. So another problem is called vanishing gradient. Okay, in vanishing gradient is when you have a paper maybe tomorrow and you don't study at all. So you unaenda kwa mtihani hauna information za kutosha. And this happens in RNN when your weights have very small number that when you multiply weight and when you do some multiplication, you get even more lower number that is approximately to 0. So over the time unapomaliza kutrain, unfortunately RNN inakopa ijajifunza kitu. So one way ya kusolve vanishing gradient is by using activation functions kama relu. Another way ya kudili na hii ni ku initialize weights and bars in a very smart way. So the last one is network architecture. Yes. Okay. So there are some technique that you can use to initialize weights and bars. So kuna watu wengine wakati wanafanya hawa initialize kabisa. The first way you have to do is try to put all weight at 0 first. Okay, that's the first way. The second way, you can randomly initialize those weights. So what? Okay. So what kitu ambacho wana advise is wanatakiwa angalau initialize weights. Okay. So there are some other techniques. Yeah, there are other techniques that how smart to initialize weight and bars, but yeah, we can explore more. Okay. So okay, the last method to do is try to change your network or network architecture. So let's see the last one about network architecture. So from RNN, from those challenges that RNN possess, they try to improve the network that the RNN, I can say RNN, by use of gates. So the gates, these gates try to control what information enters into the next neuron and what does not enter. Okay. Kwa hiyo kuna information zinakopo hazina umuhimu. Kwa hata okay, mfano hapa ninavyopresent, not all information zitakuwa kwenye kichwa chako, sorry. Kwa our brain inatumia hii technique kufilter which information is important to you and which one is not. So that is the idea of gated cell. So by introducing this gated cell, we get something called RSTM. So RSTM is it's abbreviated from long short-term memory. Okay. So key concept in RSTMs is first of all you have to have this cell that maintain states of your RNN. So it try to maintain what is the important information and what is not. What is the information that have to be passed into the next neuron and what is not. So it's like a filter. Also, this gets control the flow of information from what's going to the next neuron and what it is not. Also, this gets help LSTM to store relevant information. And also it help RNN to kind of selecting updates how how the weights are updated. Okay, so let's see. Let's take a look again. Limitation of recurrent neuron, and try to find why we need the attention and the transformers. Now let's say we want to predict the next token. The sentence here is the same one. I love to attend Emai conference. So we want to predict this word Emai conference. Now limitation of RNN, first limitation is it have encoding bottleneck. So we can say it doesn't have enough memory to understand what was previously said. Also, RNN, there's no parallelization. It is impossible to use RNN and train it maybe, let's say, train a larger RNN into a so many GPUs. Also, this RNN doesn't have long memory, as I said. So what can we do to solve those challenges? Okay, so we can say maybe let's take the input and yeah. First, let's try to look what are the what we might do to solve this challenge. Okay, the desired capability of RNN that we wanted to have so that we can predict the next token correctly. First of all, we wanted to have continuous stream of data. Second, we wanted to be able to parallelize so that we can train even larger RNN. And third, we wanted to have a long memory. Now, one way we can say to solve this challenge is to let's say we combine all our input together. First we say that we have to divide the input into chunks. Now let's say we combine them together, and let's see if we solve that challenge. So here we try to combine our input text and also we combine our output layers so that we can get output text and not a word. Now, by doing this into a classical neural network or recurrent neural network, we will not have this recurrence. We will not have the continuous understanding of previous text or previous information. Also, we will not be able to scale because there will be no parallelization into that. Also, there will be no orders, and also there will be no memory. Now, what needed to be done? Now, in 2017, when this paper attention is all you need. This paper have been this technique have been successful. Now, this technique wasn't about transformer. But in this year, this was the first time this technique used in transformer. This technique was there even before 2017. Now, this paper attention is all you need is try try to take attention technique and use it into transformer. So let's assume we have an image. Okay. Now, if we want to understand what is going on into that image or to try to caption it, we have to like scan all layers, or we have to scan all pixels of the image so that to understand which part of the image is important, to understand the context of whole image, and which part is not important. Now, after scanning it, we understand that the background is not important to understand the image. So we remove the background and then we remain with, okay. So that is the concept of attention. So in attention, we try to look the whole data set and try to pinpoint which part of the data set is important so that we can understand the whole the whole concept of our data. So let's use this example to understand more about attention. So here, this is YouTube, by the way. So let's say we want to search into YouTube the podcasting in Tanzania that speak about AI into our context. So I go and set there the AI convo. Now that search query, that search text that I put there, it's what called the query. And this text over here that explain about my search results are what called the keys. Now, those are query and key. Now, what I have to do here is to try to look the similarity of the query and the key so that I can get what I want. So if I try to look into this one, the first one, I'm not sure if that is what I want. I have to look into the next one also. Now, when I look into the next one is not what I want. I look into the next one is not what I want. And then the same way. Now it's we remain with this one. So this is what I want. Now, okay. So now if if this is what I want and I take all of that, that is called a value. So that is my value that I wanted. And the search query is the query. And the information about that search is what we call key. So in that context, we'll use this term query, key, and value. So from here, you have to understand what it's mean. Okay. So let's go back into neural network. Now, one thing we have to understand, or one important feature we have to understand how to embed. We have seen how to embed text. Now we have to understand how to encode those embedding and take its position. So in transformer or in GPTs, they are not just embedding the text and use it. They are taking the position of the embedding. Now, how do we get position embeddings? Now, let's say we have a text here. Hi, I am Isaac Odero. And we embed it. Now, from those embedding, we try to position each embedding into a certain number. So that number will be a representation of the position of the embedding. So from after getting the position of those embedding, we try to to search for query key and values. So we take the position embedding, we multiply them with the linear layers, then we get what called key, value, and the query. See, mechoka? Ni noma? Sawa. Hapo tutakuwa tumepata key, value na query. Sawa. Kwa hiyo tumejifunza concept mbili hapa. Ya kwanza ni kutafuta position encoding na ya pili ni kufahamu key, query and value ni zipi. So now let's try to understand what is attention. Okay. So in attention, what we try to do is to try to select the information that are important. Okay. So tunachofanya hapa tunachukua query and key, tunazimultiply and then tuna scale. Okay. So au kwa lugha nyingine tunasema tunatafuta attention weight. Weight zipi zina attend into an important context au important matter kwenye dataset yetu. Sawa. Kwa mfano nyie mnavyoangalia huku mbele, ndio kuna vitu ambavyo kwenu ni important na vitu ambavyo sio important. Kwa mfano background hii hapa au rangi ya ukuta au kitu ambacho kipo kwenye ukuta sio important kwenu. Kwa hiyo inawezekana unakiona lakini ukipi attention. Ndio. Kwa hiyo ndo concept nzima ya attention. Kwa hapa tunachokifanya tunatafuta hizo weights au knowledge ya what is important kwenye data zetu au kwenye text. Kwa hiyo to understand that so we can take a sentence and put it in the row and the column like that and try to understand which word is important to the other. Okay. So this is called a biograph. So you can see there hiyo diagonal ambayo ina red line ndo diagonal ambayo ina show the importance of the text with respect to another text. For example, hii iko na red na iko corresponding na hii. Okay? So unaenda hivyo hivyo. Toast D iko corresponding na toast D. Sawa. Kwa hii hapo inajaribu kuonyesha like what word is important or is important depending with what word. So kwenye sentensi mfano ukitaka kusema I am, huwezi ukasema yani au I am Isaac. Ila ukibadilisha ukasema am I Isaac, unabadilisha the whole meaning of sentence. Ndio. Kwa hiyo unatakiwa kwanza to calculate weight attention, kuangalia I, ili kujua I mbele yake inatakiwa ije am, afu mbele yake ndio inatakiwa lije jina langu, si ndio? ila kama sitojua hivyo nikabadilisha nikaweka am mwanzo, ai ikafata, ina maana nimebadilisha maana nzima ya sentence. Kwa hapa ndo tunachojaribu kukifanya, tunajaribu kuangalia neno gani lina umuhimu likikaa mbele ya neno gani, au neno gani lina umuhimu corresponding na neno gani. So hii hapo ndo inaitwa attention weight. Okay, so now baada ya kupata weight unatakiwa apply sasa hizo weight, hizo attention weight kwenye value yako, ndio tulisema hiyo yote ndio value. Kwa hiyo tukichukua key na kweli tukatafuta attention weight, tukatafuta attention knowledge ambayo tunatakiwa to pay attention to, tunaiapply hiyo knowledge into the whole value ya hiyo ku extract what is important for us to understand the context of those texts. Sasa hapa tunajaribu kuchukua key, query and value ku implement that formula. Okay. So hiyo yote ndo attention sasa. Kwa hiyo ukisema attention mechanism ndo hiyo yote, ambapo sasa kusimplify ile diagram unaweza sehemu nyingine ukaikuta iko hivi, imechorwa hivi. Kwa hiyo ni kawaida tu kwamba unafanya matrix multiplication ya query and key, una transpose key and then una scale hicho kitu, then unafanya softmax, then una apply your value, ila so lazima unania yote, si ndio? Washafanya wenzetu huko duniani. Kwa hiyo you can stack together the attention layer into multiple attention, so that is what we call multi-head attention. Now to simplify it, you can put it like that, multi-head attention. So there are two things in multi-head attention. Kuna multi-head attention and then kuna masked multi-head attention. Now to understand masked, hapa wanawake ndo wataelewa zaidi. Mnapopaka makeup mnakuwa naita ni mask. Kuna wale wengine usiku kabla ya kulala wanajipiga ile naneli, afu asubuhi anaibandua, au sio? Au mwanamke akipaka makeup ina maana, au basi kwa mfano sio mzuri, lakini hapa au ngoja nielezee hichi afu na nyinyi mtajiongeza kwenye huo mfano wa makeup. Hapa tunachojaribu kufanya ni kuficha baadhi, kuficha baadhi ya information kwenye text na kuacha nyingine, alafu tunaipa model ijaribu kupredict hiyo text ambayo imefichwa ni nini, si ndio? Kwa hivyo tunachukua text, tuna embed, tunatafuta position encoding zake, tunatafuta attention and then tunakuja tunaimask. Kuimask maana yake unaficha some embedding, afu unaipa model ijaribu kupredict ile embedding ambayo imefichwa ni ipi. Sawa. Kwa hapo unaweza ukalilete hapo kwenye kumask na kupaka makeup. Naam. Kwa hiyo we can simplify those into easy box hapa. Kuna multi-head attention na masked attention, ambapo kwenye hivyo vitu sasa ndo tunapata transformer. Sawa. Kwa hiyo kwenye transformer kuna side mbili, kuna encoder na decoder. hiyo side ya kushoto ni encoder, side ya kulia ni decoder. Kwenye decoder ndo kuna masked attention, ndo kitu ambacho kimeongezeka. Ina maana huku kwenye decoder tunajaribu kuficha some embedding, alafu tunaiweka tunaipa kwenye encoder ijaribu kupredict what was that embedding. Kwa hiyo from there ndo tunapata hiyo attention au transformer. Sasa kwenye hiyo transformer ndo zikaja hizi language model kama BERT, GPT-3 na hizo AlphaFold na Vision Transformer na kuendelea, na mpaka leo ndo tuna GPT au nadhani OpenAI O1 au O1, GPT-O, GPT-4o na vitu vingine na cloud. Kwa mwenye swali labda? Amna. Kwa in summary tumeanza kuelezea like kwa in summary tumeanza kuelezea like the history. Tumeona AI sio ya mwaka jana wala mwaka juzi, mitoka zamani. Tukaja tukaelezea perceptron ni nini, tukaanza sasa tukaelezea kwa nini AI sasa hivi imekuwa sana, alafu tukaja tukaanza kuingia sasa kwenye neural network. Kwa tukaelezea what is perceptron. Kwenye perceptron tunapata neural network, kwenye neural network tunapata deep neural network, ambapo ndo kuna hizo term kama deep learning. Kwa hiyo from there tukaanza kubuild our intuition about what is sequence data, what is sequence modeling, RNN ni nini, lakini hizo nani zote tulikuwa tunajenga kwenye kupredict what is the next token. Kwa mpaka tukafika kwenye attention. Now in summary, kwenye attention ambacho natakiwa tu kuunderstand ni kwamba hatufanyi kama RNN tulikuwa tunachukua knowledge from previous neuron na tunaiapply into next neuron, lakini kwenye transformer au attention tunajaribu kumap the whole data set and then tunaangalia which words are important to understand the context ya data nzima. Nikatolea mfano unaposikiliza talk au hapa nilivyoanza kuongea toka mwanzo, ukiambiwa urudie ukumbuke maneno nilosema huwezi kukumbuka, ila una context yani nilichokisema. Kwa hiyo ndo huo ndo mfano wa attention mechanism au transformer inayofanya kazi. Haikalili maneno, inajaribu ku map hayo maneno yote ambayo unaipa into knowledge. Yeah.
Sorry to interrupt. There is a question from Somanda.
Yeah, karibu.
Thank you. We've seen RNA have the dynamics. I was wondering if we can we get such challenge in LCN or GRN or just RNA?
Yeah, moderator unaweza ukaudia nisikie vizuri? Hello. Hello, Erika. You can just type. Wakati tunaendelea huku, mwenye swali pia huku anaweza kauliza. Vitu vingine ilikuwa inajaribu kugawanya tofauti, lakini since transformer imekuja, kila walipokuwa wakijaribu kuiapply into another field ina fit. So nowadays transformer inafanya almost everything from image, language, audio, videos, kila kitu inafanya. So all those model ambazo unaziona either inaweka kwenye video au kwenye kitu kingine transformer na transformer. Kwa hiyo pia kwenye text unafanya image, lazima uembed vile vile, alafu unapata position encoding ya
Hello, Erica.
Hello.
Yeah, so we didn't hear your questions. Can you please either repeat, because there was a sound issue, I think. So maybe if you can repeat the question, or if you can type, so that we finalize the session and we move to the next session. Our next presenter is here already.
I was asking, we have seen that in RNN.
Wait a bit, Erica. Isaac is finalizing to answer to respond to a question here, and then we're going. We'll come back to you. Yeah, I will just notify you here.
Compared in LSTM's busy elements. Of course, umesema ni self-attention module. Ila, isn't there something else hapo katikati?
So kwenye RNN,
Hey Isaac, we didn't hear you clearly. Can you go close to the microphone?
Okay. So sorry, kuna mtu ameuliza hapa swali, what stand out from transformer kufanya yote ambayo yanatokea kuwa possible compared to RNN na LSTM. Ndo nilikuwa najibu hapa kwamba kwenye RNN from classical neural network zilikuwa hazina memory at all kwenye hizi sequential data set. Kwa hiyo kwenye RNN wakajaribu kumodel memory kwa kuongeza ile H state, si ndio? Lakini H state ikaja kuwa na limitations. Kwa hiyo wakajaribu kuimplement gated, ile gate ambayo ina control which knowledge inatakiwa ipass into the next neuron, si ndio? Ambapo pia na hiyo ikaja na limitations zake. Sasa ambacho kina stand out kwenye attention ni kwamba attention au transformer ni kwamba inachojaribu kufanya ni ku map the whole data set, alafu ina select which part of the data set is important kwa context ambayo tunayo. Mfano mmoja, kwa mfano ukitry to kufanya mfano ragi, umechukua language model ukataka kufanya ragi, ni lazima kwenye ragi uipe maelekezo ya nini model yako ifanye, then utaipa input, expect output, si ndio? Yale maelekezo tunaita ni context. Kwa hiyo transformer inachojaribu kufanya ni kuangalia the whole data, kutoa context, si ndio? What is important kwenye hiyo data set ili iweze kukupa unachokitaka. Kwa hiyo hicho ndio kitu pekee ambacho hakikuwepo kwenye LSTM wala kwenye RNN. Kwa hiyo hicho au tunaweza tukasema attention weights hazikuwepo kwenye kule kote.
Yeah, so to add here, I'm sorry. So kukuwa kuna issue pia ya computation when you are dealing with RNN kwa sababu you have to do operations in sequence, ndio. Lakini with the transformers, operations are being done like you parallelize the operations. That's one. Lakini pia recently kumekuwa kuna paper ambazo zimetoka. One of them is XLSTM ambayo inajaribu kuonesha namna gani pia LSTM can be customized to perform better compared to either GPT, I mean transformer based model. Lakini kuna paper nyingine nadhani imetoka last week inaitwa RNNs are what you need. Nadhani yenyewe inajaribu kuonesha some improvements kwenye RNN ambayo inaweza kaifanya iwe better either than the transformer based models. Lakini so far ukiacha the attention mechanism, lakini pia the ile simplification ya kumap data na kufanya operations, nadhani pia ilikuwa ni part of the innovation nadhani ambayo ime accelerate hicho kitu. Lakini one thing ambayo pia ni very important ambayo imesaidia kuunify like transformer iweze kutumika kwenye video, audio, ni kutoka pale kwenye base ya how you input your data. Like kutoka pale kwenye unapofanya embedding, unapotengeneza like the tokens, unapofanya position encoding, like it's very easy sasa hivi kuchukua audio ukaigawa into chunks and then you represent them as tokens, au video au picture ukaiweka into patches and then zile patches zikawa represented as tokens zikaingia kwenye transformer. So I think that's some of the things ambazo zimeifanya transformer iweze ku unify the field like to deal with evil like multimodality and other aspects. That's from my perspective. Nadhani
Yeah, kuongezea hapo nani ili Suskeva yule ambaye alitoka OpenAI mwanzoni, yeah, Suskeva so Suskeva. Okay, so asante kwa information. Wakati mwanzo wanajaribu kutengeneza GPT, ili alichokuwa anasema these models ambacho zinahitaji ni just kulearn. Kwa kulearn kivipi? Kwamba zamani ulikuwa ukitrain model ikafikia sehemu fulani tunaacha, wana stop, lakini wakaja wakaimplement ile kuongeza parameter na kutrain more. Yani hata kama imefikia sehemu pazuri, unaendelea kutrain, unarudisha more zile data, unarudisha una train tena. Kwa hiyo anasema from overtraining kuna more insight ambazo zinaweza kupatikana, na hiyo yote imewezekana kwa sababu ya parallelization ya transformer. Ya swali lingine kama lipo. Mzumbe uko na swali.
Hello. Yeah, so Erica, you can ask now, but we just use 1 minute and then we proceed to the next session. Hello? Okay, I think you can respond to it. You can just finalize then.
So yeah, yeah,
so she was asking about the problem of gradient descent. Is it also possible in other algorithms like LSTM?
Gradient descent.
Yeah.
Yeah. So.
Okay. So gradient descent is just an optimization technique. So it's done in all of neural network, either LSTM, RNN, and both of them. So to put it in context, gradient descent is just a way to find a minimal weight and bias that can help your model to fit your data set. Yeah. So yeah. So you can do it in RNN, LSTM, and all of them. Yeah, kama hamna swali lingine, asanteni, na tuta provide notebook ambayo inajaribu kuelezea kwa kutumia Python how to do this positioning coding na embeddings na hizo technique ambayo tumeongelea hapa mwisho. Na pia kama unahitaji kujifunza zaidi, kuna blog yangu unaweza ukaenda, ni odero.github.io. Ni static page, sio ukajua static page tu nimekaweka GitHub. Yeah, odero.github.io. Yeah, kwa asanteni.
Yeah, so thank you so much, Isaac, for that insight presentation. So we will share the notebook and the slides later today. And now we are moving to the next session from Victor. Victor, can you hear me?
Yes, I can hear you.
Yeah, thank you so much. So yeah, so I think you can proceed.
Yes. Yeah, I'll share screens.
Yeah, let me give you.
Yeah, I need permission.
Yeah. Yeah, I think you can share now.
Yes, okay. All right, can you all see the screen?
Yeah, we can see it.
Yeah, I don't know how it looks like on the ground. I only see the people in Zoom. So I don't know what the setup is like there, but hopefully you can see the screen, and I don't know if you can see my face. But yeah, so in the previous session, you got to see a little bit about the deep dive into the actual multi-head attention of the large language models and how the transform architecture works. I'm going to be a lot more higher level. I'm going to talk about how you can actually build using these, because a lot of the things you might have learned in the last one is very useful to know if you want to start implementing some of these things yourself. And when I say implementing, I mean like designing the architectures or even training the models. But most people, the main use case for it is to actually build applications using inference rather than training the models. So that's what we're going to do. And specifically, I'm going to look at open source language models where the weights and how they're trained, all of that is public information. And I'm going to be looking at a case study on Twiga, which is a project I've been developing this year with the Tanzania AI community. But first of all, who the heck am I? I was actually in Tanzania in February and March of this year, doing a field study for my master thesis. And I'm studying at the Royal Institute of Technology in Stockholm, called KTH. But I've also been at EPFL in Switzerland. And I've been studying mostly industrial engineering and management and machine learning. But for my master thesis, I wanted to look more into generative AI and look at how large language models specifically can be used in education applications, and that's what Twiga is. But I'll talk more about that later. But despite that, despite my background in machine learning and sort of this more technical aspects of working on these kinds of products, most of what I know about specifically generative AI is self-taught, and it comes from working on projects. And I started out basically testing out how I could use OpenAI's GPT 3.5, GPT-4, using their API or application programming interface. So I just created an account on their website, made myself an API key, which is like a secure code to be able to access their API services. And then I just used it. And it's a very simple with a few lines of code. And of course, I already knew at this point how large language models worked in a sort of overarching way, but it's not something you really need to know that well just to try it out. Then I studied a thing called RAG, which stands for Retrieval Augmented Generation. And that was mostly to understand how the data flows between these different components in the RAG architecture. And the idea behind it is to make large language models better at adapting to specific contexts. So if you want to create a chatbot that's able to, I don't know, book a restaurant for you, then it needs to know what kind of, if there are any tables available and stuff like that. And just with its pre-trained data, it's not going to be able to know that. So you need to provide it with data sort of on the fly based on what the user's asking for. And then I watched a bunch of YouTube tutorials. And this is specifically for Twiga. I also watched tutorials on how to build WhatsApp chatbots because Twiga is actually built into WhatsApp. And then I started looking at the documentation for the different APIs and the different tools I could use, like software development kits and stuff. And some of the popular ones, LangChain, OpenAI's API, Fast API, and Fast API is specifically if you want to build like a server, like a Python server backend, and I'm using that for Twiga. But then also Meta's API, which you need to interact with WhatsApp, and then also Grok API if I want to use open source large language models, but I don't want to host it myself. And I also found recently there's a thing called Together AI, which is even more scalable than Grok. So I'm going to talk more about that later because it's quite interesting. And it's something that we're going to be building and adding into Twiga within the next week. And then I just started working on random projects and sort of hacking away. And I continued reading the docs while I was doing this. So it just takes a lot of effort to get going, but it doesn't require a bunch of expertise in any specific area. You just have to be committed. Okay, let's talk about Twiga, what it is, and how we built it. Well, it's like I said, it's a WhatsApp-based chatbot. And the idea behind it is that it's supposed to provide teachers in Tanzania, specifically secondary school teachers, but hopefully in the future also primary school teachers, with a tool that allows them to directly communicate with essentially the textbook content for the courses that they teach. So if I'm a geography teacher, then I can just text this chatbot, and it, using retrieval augmented generation, can fetch relevant information from the textbook based on what the teacher asked, and then create a response which is grounded in what the textbook and course curriculum actually requires. Meaning that if I, for example, ask it to create an exercise for me that I can give to my students, then it's going to create exercises that are related to the course material and not just some random topic in geography. And I'm using GPT-4o in the current version, but we're also using Llama 3. And we actually, due to our use of Llama 3, we recently were provided the Meta Llama Impact Innovation Grant, which is a $50,000 sort of reward to help build this further. And that shows you the sort of the power of using open source models, because there's a whole community around it, and people get very excited when you start using the models, especially Meta, who are the founders of the Llama large language models. but we're planning to go a step away from using GPT-4o and focus purely on using open source large language models and staying in the spirit of open source development. Yeah, so I've been ranting a lot about these language models and the RAG setup. So I'm going to explain in very short and brief detail what I mean by that. So of course you have the language model inference, and like I said before, you heard some intricate details on how the actual structures work in the previous presentation. And that is very important when you're designing the actual pre-training process, when you're training these models with billions or trillions of or billions of bits of data. But usually you use it for inference once you've actually trained it. And it's simply you just write something to the model, it tokenizes it, and then it interprets it, and then it pushes it through this entire transformer architecture, which is called inference in this case, and then it generates a response for you. So that's an overview. But then retrieval augmented generation adds a few steps to this whole process to make it even more convenient for real-world applications. So what you do is when you write a user query, so in step 1, that user query is parsed and embedded and converted, into a vector essentially, which is not really important how that's done. And then it searches a vector database of relevant information from textbooks, for example, or course curriculums, anything that you want. It could even be images. And then it finds that information and it puts it into the message that you will send into the language model eventually. So the context here in step 3 combined would be that. And then all of that goes into the language model. And then it conducts inference, not just using the query that the user sent and also its own parametric memory, but it also uses the contextual information that you gave to it to generate a more contextualized and appropriate response than what you otherwise would have had with just the language model. And in Twiga, it's a little bit more complicated because we wanted to make it better, and we wanted to use some of the state-of-the-art techniques that exist today. And keep in mind, this was designed back in April, and it's only been a few months since then, but this is already no longer state-of-the-art because there are new things that come pretty much every other week. But in a simple sense, for this RAG pipeline, what we do is we rewrite the teacher query, because if they're really vague in what they ask for, it might be helpful to rewrite that using a smaller language model so that when you actually search for relevant information, it's going to be able to find more specific and nuanced stuff. And with that search query, the rewritten search query, you can retrieve some sort of content. And in Twiga's case, if we want to generate exercises, then we create both content and exercises, or we retrieve those. And then we use what's called a re-ranker, which is basically a cross encoder. It's a fancy word. You don't need to know exactly what it does, but it just reorders the search results in a more sophisticated way to make sure that only the most relevant things that you fetched are actually added into your prompt that's sent to the language model. So now that's how Twiga's RAG pipeline works. And I can't even remember what the next slide is. Oh yeah, how to get started. So like I said, you don't need to be an expert. You don't need to have a degree in machine learning or AI to be able to start doing any of this. What you really need is quite simply just a computer, access to Wi-Fi, and a really basic, limited understanding of how Python works. And you just need to be committed and willing to learn new things. Because, and I'll show you soon, the kind of code that you need to write to get this to work is very simple. And the APIs that are provided by OpenAI and some other services give you really good documentation that explains to you exactly how to do it. But before you can actually write the code, you need to have a decent setup. And I have a suggestion on how I think it should look like, the setup that I use, which is very simple and it's also completely free. So you can download an integrated development environment or an IDE called Visual Studio Code. Or alternatively, you can use Cursor. There's a lot of hype around this AI code editor called Cursor now, which basically looks exactly like Visual Studio Code, but they've connected it with your language models of choice, so that when you're coding, a language model will be able to see your entire code base and be able to suggest further edits for you. But I haven't moved into that yet because I have already integrated like an AI sort of tool into my Visual Studio Code. So I feel like I don't need it yet, but maybe I'll transition one day. Then I also use Claude 3.5 Sonnet. You can use the free version. I have the paid version. It's cheaper than the OpenAI subscription. And Claude 3.5 Sonnet is by far right now the best programming large language model that's sort of generally available, because I think it's better than GPT-4o and even GPT-4 O preview or whatever it's called, or O1, that's what it's called. And using this setup, you can go to the documentation of the most simplest generative AI application programming interfaces, and then you can start copy pasting some of the code and just seeing how it works in a simple way. So for example, if you want to try out OpenAI's application programming interface, I'm going to start saying API from now on. What that whole thing does is quite simply that it gives a developer access via the internet to the servers that are hosted by OpenAI. Because one thing that a lot of people think when they think of generating LLM applications is that you need to host these models yourself. You actually need to have a server that runs the large language model for you. And that's a lot of work. And most of the time, if you try setting up something like that on your own, you're not going to end up with something that's actually fast. It's going to be really slow. You can use some really small language models, like 7 billion parameter models or 1 billion parameter models that you can actually run locally on your computer. But in general, if you want to run the really powerful stuff, then you want to use inference with like OpenAI servers. And you can see how this is a really, really simple. It's 15 lines of code. All you do is you import OpenAI's software development kit, and then you create a client. So you're the client using their services. And then you basically create a completion. So that's just running inference on their models. You select what model you want to use, and then you put in a few messages that are formatted in this exact way. And then you have the response provided, as long as you've given, of course, your API key to them. So it's very simple to use. And there's also, of course, the open source models, which is what this presentation is about. Since the OpenAI API was so convenient to use, a lot of open source model providers have copied the exact format. So the code example you see here is from Together AI's API, and it's pretty much identical to OpenAI's setup. And it's the same setup. You just write to it this exact thing, you run the code, and then it generates a response for you on their servers. So yes, and of course there's also a Grok API, and they're incredibly quick. Like they can generate thousands of tokens per second if you're running slightly smaller models. They're much faster than OpenAI's API and their inference servers, but Grok is also sort of limited in its scale since it's still a startup. So they have quite low rate limits unless if you get like an enterprise sort of subscription. But yeah, then of course, I've shown you the basics, but you can take this a step further with some more interesting applications. I really recommend becoming an open source contributor because it's a really nice way to get yourself, even without any experience, into the world of development and putting your name out there on the web. And a very simple sort of 4-step process to learn how to do this is you learn how to use Git, which is source control. And that basically allows you to keep track of what changes you're making as you're coding. And then Git is a local thing. And of course, it's nice to have some programming basics like Python before this. And Python is, if you want to get into AI development, Python is the language to know. But Git, like I said, is a local setup. You'd really want to start collaborating with people online. And GitHub is a hub for projects that are using Git source control. And on GitHub, you can explore a bunch of interesting projects that are often very welcoming to new contributors that don't have much experience. And what you do is you look for tasks or issues that are created by these open source repositories, and they're called good source issues or good first issues. So if you find those, then that might be a good place for you to start, because it's quite daunting to jump into a big code base with a lot of stuff and not know where to start or how you can contribute. Because how can you contribute if you've spent one day on it and the other developers that are working on it have been on it for 2 years? So it's very difficult to catch up. But with the good first issues, that means that you don't need to understand how everything works in order to actually contribute. So what you do to do this contribution is you read the documentation provided by these open source projects. And of course, in that case, it's very important that the open source project provides good documentation so that you know how to run the code yourself. So this is an example of Twiga's repository. One of our good first issues is quite simply to rewrite our documentation in Swahili. Because I don't speak Swahili, I think you can figure that I don't. So I like having people that can help me in Tanzania that are sort of rewriting the documentation that I wrote in English in Swahili. So obviously you don't need to know how the code works. You just take mine and translate it. So it's a nice way to contribute to the open source community. So I wanted to help you guys find projects that are worth taking a look at if you want to be a contributor to open source projects. And if you're a coder, there's the URL, or sorry, there's the QR code on the left. And if you're a non-coder, you just want to contribute more with like documentation or images or whatever, then there's the link on the right. So I'll give you a few seconds to actually scan these. But I think you'll get the presentation afterwards. So if you want, then you can scan it then. Okay, another thing, if you want to get into the more nitty-gritty details of how open source models work and you actually want to test it, maybe you want to run something on your own computer, like a smaller model, or you want to look at image generation models, video models. A lot of this stuff is available on a platform called Hugging Face, which is a French company that basically provides this one website, one location, which keeps track of all of the open source AI models. And you see Meta or Facebook, they have an account there, and they release their open source models there. So if you want to find the newest stuff that's out there, you go to Hugging Face and you can try it out. So I want to give a hot take on what I think the future of AI will look like within the next few years. Not in the long term. I will have no way of predicting that, but more in the short term. And we'll see what role open source has in that. I hope it'll be a big one. So my 3 takes, I'm only going to give 3, is first that open source foundation models, and when I say foundation models, I mean things like large language models or image generation models like diffusion models. They're going to put a lot of pressure on AI safety, because it's difficult right now for even closed source large language model providers to make sure that the output their models provide is safe. So what they often do is they put guardrails on it, which essentially just has another language model read what the output of a model is, and then it checks, is this safe? Is it revealing how to generate an atomic bomb? Or should I, in that case, if it is, should I block it and not say that this is, or and say that this isn't safe? So closed source models can do that, or companies can do that, and they struggle with it anyways. And it becomes an even added layer of complication when you have models that generate videos or that generate images. There are risks of them being trained on images which are dangerous in some way. And even being able to generate after the fact images that are dangerous, such as photos of presidential candidates or videos of presidential candidates doing something bad, which might actually sway public opinion in some way if they believe it's true. And with open source model, this becomes even more difficult because you don't have this extra layer, since people have access to the models in their purest form. And another take of mine, I'm not going to sit too long on each point, is that large language models have already shown that they're very much capable of doing a lot of things that humans can do online. And therefore, I believe that AI agents will take the main stage. And by AI agents, I mean something that can interact with things online, not necessarily online, just in general, and perform functions or actions for you as a person. So, for example, it could book a seat at a table for you at a restaurant, or it can book a flight for you, or it can do research for you to find candidates to apply for a job. So there's a bunch of stuff. In this case, on the right side, you're seeing an example of Perplexity, which is basically a search engine powered by large language models, and it allows you to search the internet. So that's a very simple version of an agent. But in some way, I think that these will just develop further and further until you could probably interact with most of the internet without even going to their websites. You could have a large language model actually read the HTML code of the website, interact with them for you by finding the CSS selectors. And all you have to do is interface and talk with a chatbot. You might even just do it verbally and say, hey, can you book a flight for me? And then it'll find the website, read the website, and do it for you. So it'll be sort of like Jarvis in Iron Man, if you've seen that. So I think that's really cool, but also kind of scary because it'll change, I believe, how sort of search engine optimization and stuff works on the internet, because a lot of the time it won't just be people that are going and clicking on websites and stuff. You'll also have these AI agents doing it for you. So that's going to become it's going to start competing with the use that people have on the internet. Another thing is these models have shown that they're really, really good at reasoning through problems, especially now that OpenAI has released this O1 version of their large language model, which is capable of sort of self-prompting. They're using reasoning tokens. So it's able to think a lot for itself. And that's been an issue in the robotics industry, where you have these robots, these physical things, let's say a humanoid robot, which is capable of doing things, but it can't really choose what to do. You can tell it to go from one location to the next, and it'll be able to, using AI, navigate through space and find its way using like visual SLAM algorithms or something. But the idea of it being able to say, okay, it looks like it's, I don't know, very messy here. Maybe I should clean the room. That's something you would have to that's a task you would give it. But with these reasoning capabilities, it's able to understand its environment and make these decisions itself. So again, that adds a layer of risk, but also a lot of opportunity. And I want to show you an example of what I mean by this with a video from a company called Figure AI that showed this demo a few months ago. I might have even been a bit more than that. And they're using OpenAI as a brain to take images of the environment and then interpret it, and at the same time talk with the person standing there. So you'll see the video now. There we go. First of all, can you hear the audio? Can someone confirm that they hear? Can you hear it?
Yeah, so we can't hear it.
Okay. In that case, if you can't hear it and it becomes an issue, I can just explain what's happening as it's going, yeah? So let me know
In
if you.
figure one, what do
if
you
you
see
can.
right now?
Yeah, we can hear it. We can hear it, I think.
Okay, cool.
I see a red apple on a plate in the center of the table, a drying rack with cups and a plate, and you standing nearby with your hand on the table.
Great. Can I have something to eat?
Sure thing.
Great. Can you explain why you did what you just did while you pick up this trash?
On it. So I gave you the apple because it's the only edible item I could provide you with from the table.
Great. So based on the scene right now, where do you think the dishes in front of you go next?
The dishes on the table, like that plate and cup, are likely to go into the drying rack next.
Great. Can you put them there?
Of course.
All right. So how do you think you did?
I think I did pretty well. The apple found its new owner, the trash is gone, and the tableware is right where it belongs.
I agree. Thanks, figure one.
You're welcome. If there's anything else you need help with, just let me know.
All right. So I thought when I saw that for the first time, I was super fascinated. But of course, in hindsight now, I've thought a little bit more about it. And I believe I have an understanding of how they created that demonstration, because I don't think that the level of capability of these models is quite there yet, just face value, because obviously this was a demonstration. So they're showing what it could be capable of doing. And I believe what they're doing here is they've given this bot, the OpenAI GPT-4o or GPT whatever, and they've given it a bunch of functions that it can do. And one of the function is to take the dishes and put them in the right place. And another function is to give him something to eat or an apple or whatever. And then when he's talking to it and he asks for these things, it knows that it has those functions available to it. So it actually calls on that function, and then the robot body takes over and actually performs that action, which is, taking the apple and giving it to him. So of course it's slightly, I believe, fake, but it just gives an example of where things could be sort of truly within the next few years. So I think it's really, really promising and a very interesting application of sort of humanoid robotics. Oops. There we go. Conclusion. So, of course, this whole presentation was more about becoming an open source developer, and the video I showed you there in the end was more of a curiosity, because that's not open source at all. It's very much a private company working with a private OpenAI company. But what I do want you to take away from this presentation is that contributions in open source settings sort of gives you the experience on working on these projects, but it also gives you exposure online to other developers, not just in Tanzania, but also globally, so that you can show your skills, and eventually it might give you a job. And then also using generative AI, it's important to try it out, because you don't need to study AI at university to actually become an expert in using these tools. I would say that maybe 5 to 10% of what I know about AI comes from school. Like the other 90% I've been learning on my own. And I want to give you a really interesting example of a woman called Sarah Drasner. I don't know if any of you have heard of her before, but back when the story about her is that she studied, I think she studied photography and painting at her university in the United States. But it turns out that she wasn't really interested in getting, or maybe not, didn't want to get into that field purely. So she started contributing to open source projects online. And she became a very consistent contributor to a project called Vue, which is a sort of a JavaScript framework, which is very, very popular. And her contributions over time became so good that the Vue team actually wanted her to join the core development team. So that's what happened. She became a core developer of the Vue project. And now, today, she's become the senior director of engineering at Google, even though she has no academic experience in the domain whatsoever. So I thought that was quite an inspirational story, which shows the power of working in open source AI projects, or just open source projects in general. And finally, since we've been talking about open source projects, I want to plug the Twiga project because we're building a community of open source developers. So we have a Discord server where you can ask questions directly to me. And we also have a open source repository with some of these good first issues that you can test out. So I recommend what you do is you join the Discord server. You also open the GitHub repository, star it or watch it. And if you want to start contributing on it, you can fork it and start working on it yourself. Within the next 2 weeks or so, because right now I'm working with another developer in Tanzania to create like a sort of a relatively stable version of Twiga, because right now I've built many iterations before. But the idea is within 2 weeks, and then 1 week further, we'll start creating a really, really good documentation for this. It's already okay, but it can get better to allow open source contributors in Tanzania to contribute to this project and make it available to teachers all around Tanzania and hopefully even other places. And yes, I think that's all for this presentation. So thank you very much. I'll leave this screen open for questions as well.
Yeah, so thank you so much, Victor, for that insightful presentation. So let's see if we have questions or any addition. Yeah, so questions. I think we had voice. So from Nelson Mandela or any other?
I can't see the chat, so, oh, I guess I can. There's nothing in the chat. No.
Okay.
In that case, I'll stop sharing my screen.
Okay.
Cool. All right, so if there's any questions, you can join the Discord server and ask me there, I guess.
Yeah, very true. So I think we don't have questions, but if you will have a question, you just let us know, and then we can reach out to Victor and respond to it.
Yeah.
Yeah.
Thank you very much.
Yeah, so otherwise, thank you so much, Victor, for your time. I think we'll keep in touch, and for the Twiga project, I hope to get more contributors from the community to push it forward.
For sure.
Yeah.
All right. Thank you very much.
Thank you so much. Yeah, so we are having a break, then we will be back. So we are supposed to have lunch from 2 p.m. That means we'll be back for the next session 8:45. I mean 2:45.
So are we going to break now or around 2 o'clock?
Yeah, so we are having an activity here. We're having an activity here, so that means it's going to extend to lunch break, and then we will be back at 2:45.
Okay, thank you very much.
Yeah, yeah. Yeah, so we are back for the next session. Tumechelewa kidogo kama dakika 25 nadhani.
Date last attended. Hii ya mwisho tumefanya mwezi wa 7 Julai 2023. Date DB award ni cheti. Mcheto andiko kwa tarehe kubwa. Waona hapo hapo bani. Itaiwahi kweli? Mpaka tarehe 3. Mpaka tarehe 3 Novemba itaiwahi. Tarehe 3 Novemba. Wiki mbili 14 ukijumlisha hapo. Tarehe 20. Yaani kifungu hapa na nani? Maliza issue that transcript. Chapo. Ukishamaliza transcript nasikilizia wiki moja baada nenda. Kachukua mtambo. Yani nimepata nimaliza kila kitu. Shida ni password. Shida kwa password. Ndefu. Format yake na isi ndo tatizo. Bado sijajua shida exactly ni lakini nikumbuka shida ni password. Maana SSID saizi ina load vizuri la nikiweka iridi password ambayo inakuwa stored kwenye EEPROM ndio inarudi kwenye default. Na ile default inakuwa loaded na tensor kulingana na MAC address yake. Okay. Version ni format. Ile na mega pinga. Sasa anaenda sema nini anataka kusema? Kwa nini anasema mnataka? Anaenda kusema. Pasa na kupata kama hicho. 23 kitu cha kawaida 2023 Novemba. So yeah. 23 Novemba. Tulikuwa tuna play. Ami hivyo vipo Novemba. What is the name printed in the traffic? It's only in side. Hajaiara kule wakati nimeanza kujisajili. Suffix, suffix. Inaonekana kuandika hivyo hivyo. Ndio kitu chako takiprint hivyo hivyo.
Hello, Boniface.
Admin. You must make a
Boniface, hujamute mic yako Boniface.
cancel kwanza.
Boniface, hujamute mic yako tunakusikia.
So what's the next session? Ambaye anajua ratiba. Okay. So we are remained with 2 sessions. Okay, let me check here. Yeah, so we are going to do reinforcement learning from human feedback, and then we'll be having the last session on foundations of multimodality from Yusuf Shongolo. Okay. Yeah, so let's do it. So to proceed with the session, I'm going to start with this. So this presentation actually, which I'm going to start talking about, is a presentation which was presented last year at Microsoft event by Andrej Karipath, Microsoft Build. So I'm going to to look on some few things from this presentation, and then I'm going to talk about reinforcement learning from human feedback. Okay. So he discussed a lot of things, so I'm going to be skipping some of the things. Yeah, so here's the an overview of what he discussed it on training a GPT assistant. And there are 4 stages when you want to train like a GPT model thing. So the first stage is the pre-training stage. Let me expand this. So there is pre-training, and then we have supervised fine-tuning, then we have reward modeling, and then we have reinforcement learning from human feedback. So the focus of this session is we will just have an overview of what is happening at that final layer of training pipeline, the reinforcement learning from human feedback. And to just just an overview of what really happens. For instance, at stage 1, you have raw internet data, like you do scrapping of the internet, and then you have trillions of words from text. And as you can see, there is low quality and large quantity. That means the data set it's very large in size, but the quality of data is possibly low because you are taking everything from the internet. And the second step is to choose an algorithm. So you have data, and then you have algorithm, and that is actually the transformer to predict the next token, as what Isaac was talking about. And then after putting data or training an algorithm from the data which you have curated, then you're going to have a base model. So a base model is just sometimes it's referred as foundational model. So it's the model that can only predict next token. So it doesn't know anything. Hello? Let me see who's not muted. Hello, someone talking there?
Sorry, I was forgetting to mute the mic, but you can proceed.
Okay, thank you. Okay. Yeah, so after you do training, like you train that specific algorithm on those bunch of text data, you get a foundational model. So foundational model is just a model that is able to predict the next token. It's like a sentence completer. So you give it a sentence and it tries to complete it without understanding what is actually has to be done there. So that is what happens. And there is few notes here of what is needed. So you need 1,000 of GPUs, as we discussed yesterday. So you need 1,000 of GPUs, and then you need months of training. So that's what you need, for instance, for then you're going to get GPT, Llama, or PAM model. Yeah. And okay, what I was trying to say. Yeah, so you can deploy it, but the thing that's going to happen, like, it's going to be completing the documents which you are giving them. And the second stage is to do supervised fine-tuning. So in supervised fine-tuning, the main concept is like you want to downscale it to a very specific task. So you want it to perform a very specific task apart from either completing documents. So we just need some few data that is prompt response. That's what Onani showed us yesterday, the prompt response data, and they might range from 10 to 100K samples. And sometimes they can be written by contractors, like the people you hire people to create them, like to create prompt and responses. Or currently, most of the people, they use synthetic data actually from the large language models themselves. So, and like at this stage, we are going to have low quality data, but high quality. So that's what is going to happen there. And then it's going to be able to do language modeling, like to predict the next token. And what you're going to get there is FT model. So a FT model is supervised fine-tuning model. And requirement, you see, like, you moved from thousands of GPUs, and then you are now in range of 1 to 100 GPUs. The concept is, like, to do it from scratch, you see you need 1,000 GPUs. And when you do a fine-tuning approach, you reduce the cost of maybe considering to train from scratch your own model, and you can deploy it. So another stage which I want to talk about, then we're going to move forward, is reward modeling. So reward modeling is you're going to have like taking the responses of a specific language model, and then you are going to give them like you rank them based on how correct are they. For instance, it happens to me, I don't know others, when I prompt GPT, sometimes it can bring like 2 responses, and it asks me to choose which one I would prefer. So it's like you are creating a data set for doing this kind of reward modeling. So let me go to the slide which explains this part. Okay. So this was like the overview of the data set that's one might need. So this is like the data which was used to train. I think he was talking about Llama 2 by that time. So there's a Common Core data set, which is 67%. There is data from GitHub, C4, Wikipedia, books, ARXIV, Stock Exchange. So these are sample of the data proportion, but also we have the epoch, and we have the disk size. So for me, actually, I don't even have an idea of having a storage of 3.3 kilobytes. But that's what actually was needed to store the data. Then that's about data. So data collection, collect a large amount of publicly available data. And then here's what Isaac was talking about, like to train a model. First, you'll be having the raw text, and then you're going to change them into tokens. So there are different algorithms or techniques to do tokenization, but the most common is BPE, byte pair encoding. But the more natural way of encoding, you can say, like dividing words like to separate the spaces. So for instance, you can see there are different colors. So when you use technique like because it's like a technical session, you can go on your browser and then you can search for GPT tokenizer, I think. And then when you type there some words, you're going to see how they are going to be tokenized based on that specific algorithm of how it works. So I want to go into details how it works, but there is different tokenizers, and there is, I remember one word piece tokenizer, but the most common or the natural one is just splitting words based on the space. So for instance, for the statement like the GPT family of models processes text using tokens. So you could have like token, there is going to be a single token, GPT a single token, family single token, of single token. So you're going to have like 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're going to have like 9 token based on that single statement. And after you have tokens, you're going to create like token IDs, which is integers, and these are representation of the tokens that has been created, the second step. And these tokens are like the integers, or the token IDs are what are going to be used then to train the model. And specifically, something is going to be added, that is position encoding. The position is to identify, like in this specific document, GPT came before there. So we are going to like to add the position encoding integers, and then we are going to create the like some sort of embeddings which will present the position and that specific keyword in that specific document. So that's the second step. So you have, and here there are some details. Like the first one, you have, okay. Yeah, you transform all the text into one very long list of integers and typical numbers. It might be from 10 to 100K tokens. And the approximation, one token is equal to 0.75 words. And when you are using byte pair encoding algorithm as your tokenization algorithm. So let's go to the second part. So here's it's like the, okay. Here are some of the details of how some of the model were trained, like the number of parameters and everything. So for instance, for GPT-3 small, it had 125M parameters, and it had 12 layers, and it had the model dimension, or like the input dimension, was 768. Number of head, Isaac talked about multi-head attention. So that's what number of head, like there was different 12 attention heads. And then we have the head, batch size, and learning rate, which were used. So these are some of the details about those specific models. And here are some of the like the training, like training metrics for those specific models. So as you can see, for roughly, there is like you need from 1,000 to roughly 10,000 GPUs, and you need like 1 month of training. And you can see the costy money-wise, you need like from 1 to 10 M USDs. And that's what we were talking about last day. And here is when you want to train like a 65B model. Here are roughly approximations of what you need. And this is for Llama, which was released actually last year, area last year, I think. Yeah, so let's go to the pre-training. So we talked about pre-training yesterday a bit. So in pre-training, you need two things. So you need to have the batch size, and then you need to have the context length. So you'll be having a very large document, and you need to pass the data in batch wise. So you're going to decide how many batches I'm going to be using, but in each batch, what is the maximum context length. And so there is this example here of a very simple document. They shows like it has like 10. It has like the context length is 10. Like you can see from the second, like the first law is having 10 token ID. So that is the context length. And when you talk about batch size, you can see we have 4 columns. I mean 4 rows, and we have 10 columns. So the columns represent the token IDs, and that is context length, and the rows represent the batch size. That means we're going to be taking 4 documents at a time. Yeah. So to separate documents, as you can see, you have to append that end of statement token. I mean end of text token, like to make sure like the model understand like this the end of this specific document. Yeah, and then he tried to show what happens. So Isaac talked about the transform architecture. So what you do, you just take a certain specific part of your document, and then you feed it on the model. So when you feed that specific part of the document, and when you provide the next token, the model has to be able to predict what is the next token ID. That is the next token prediction. And you can see the green color represents the random highlighted token, like a token which you can randomly select and feed into the model, and then the model has to provide the response. And the yellow represents the context. So in this case, the context, we fed it to the model is that one. And then the red is the target, or what the model has to actually predict. So nitaenda chap. So here shows like he tried to train a model on different number of iterations, and as he continued to train, the performance of the model actually improved. So he had this document here, the training data, like the Shakespeare document, and we need the model to be able to complete or to predict next token based on this document. And then he did a random initial, like at the initial, like when the before training, let's say some party at the initialization, this is what the model predicted, like the tokens which it predicted, like a very rough thing. They are not understandable, and yeah, you can actually not understand. Possibly these are the words which you speak when we are kids. But as he continued to train, you can see here, after 250 iteration of training, then were some improvement of getting some very clear connected characters. And then after 500 iteration, it continued to improve. Then after 50,000 iterations, you can see like you're getting something. And after 30,000 iterations, it's like you can get some meaning words from that specific document. Yeah, so nimesema sipitii yote, ila naona kama napitia yote. Mungu atufanye kitu kimoja. Yeah, hapa sasa like it shows the training like loss for like based on number of tokens, and then he showed for Llama 3. So as you can see, for the blue color represents Llama 3. This was Llama 1, yeah? 7B. And this is 13B, and this is 65B. So as you can see, as you increase the number of parameters, you get the model performing well. So this is the very simple concept of scaling laws. So if you haven't explored about scaling law, they explain how when you combine the data, like you increase the number of tokens, and that means when you increase the number of tokens, it will need you to increase the amount of GPU you need. And then from there, you're going to get a model that is having very large number of parameters. So from there, you get a model that is performing well. That's why the trend was creating models with large number of parameters. But I think the trend is just shifting. Now people are focusing on small models, I think. Yeah, so, and here's just the, like some of the tasks where you can, like when you, tasks which you can perform with transformer. My brother there asked the transformer, it can do a lot of tasks, and here are some of the simple configurations. So when you want to do classification, you deal with transformer, but at the end, like at the output layer, you have a linear layer, which is going to output the probability actually of that specific classification problem. And when you want to do this interment, then you need also a linear layer. But for similarity, you are going to have two transformers, which are going to take like the first statement and the second, and then you're going to compare the sentences. Then you are going to have a probability, like a similarity score between the sentences. And for the case of multiple choice, then you're going to need different layers of transformer to give the scores to those multiple choice issues. So let's move chap. So in kama load map, like there is a lot of large language models. Unfortunately, possibly we know mostly GPT, but there is a lot of large language model from 2020, I think 2029 to current state. We have a lot of, so there are open source and non-open source here. Yeah, as you can see here, there is open source and cross the source. Let's do something else here. Yeah, and for those who want to get a good understanding of the transformers and some of the history, you can see there are papers here, like the first GPT paper. It was released in 2018. You can read about it. GPT-2, GPT-3, Opit, Palm, Broom, MTNRG, Gram, Gopher, Chinchilla. This was explaining actually about the scaling laws, Lambda, and then GPT-4. So GPT, after like they released ChatGPT, most of the papers become like they were not having too much information because it became a business then. So they started to hide some of the details or information about their model. And as you can see, GPT-4, it was just like a technical report, and it wasn't having too much of information of maybe number of parameters, how much compute they use, how long did they train the model, and all that. Yeah, so that was it. So I'm going to move chap. So that was the first pre-training stage, then fine-tuning. So I'm going to skip fine-tuning. So this is reward modeling. So I wanted to talk about a bit about reward modeling. So in reward modeling, you have responses like this. So you ask like GPT to perform multiple tasks, and then you rank the responses. So you say, maybe I prefer this, then that one, then that one. So when doing that, we are creating data to train back the model and to tell it like, hey, when creating responses, you have to focus on what user actually needs. And that goes to the concept of preference or human feedback. So it's like human giving feedback to the model, telling like, hey, I prefer these responses over these. So that is ranking. Like we create ranks between the responses, and that's how we create data. And then we're going to train the model to understand, like to reward it, to reward the model when it gives actually what human prefers, let's say. So it's going to be doing that. And I don't remember actually most of the technical details here, but the concept is you have the model creating responses, and then you reward it when it gives what you, what human either ranked first based on their preferences. So, and then you go to reinforcement learning from human feedback. So the essence at the reinforcement learning is like, it is something similar. The issue is, for instance, for OpenAI, I don't know the current state, but in previous versions, they hired some people to be rating the responses, like the GPT responses. Most of them were Kenyans, and you can follow that story. Like there was an issue, like they hired a lot of labelers and they were paying them very low amount of money to do a very bigger task. And when you are given a task of creating those data, like to rank them, there is a contract, like you sign a contract. So if you feel like you can't rank something, like maybe I get a response and I feel like I can't rank it in any way, I just leave it blank. So like you should not rank anything that you are not sure of. That's one of the essence. So the issue with reinforcement learning from human feedback is actually to maximize generation of tokens that maximize reward, or that maximize the possibility of giving out responses which are preferable to humans or to users. Let's use that term. So, and when you do reinforcement learning from human feedback, you're going to create RL model, that's the reinforcement learning model, and you're going to use very minimal amount of compute, and the output is going to be ChatGPT. So as you can see here, the output is going to be a GPT, like a base model. But when you do reinforcement learning on it from human feedback, you're going to create ChatGPT, which is actually able to do conversation in the way we need. So that's the very simple concept. So there are different techniques if you want to do that, reinforcement learning from human feedback. Unfortunately, I won't go in deeper, but there is direct optimization policy, that is DPO, and there's PPO too. So I think PPO is proximity policy optimization. I don't remember the short, but there is PPO and DPO. You can explore them for the case of creating like RL models. Yeah, so this presentation is actually on the internet. So if you want to explore more, so here is like trying to explore what happens when you have just a model. For instance, you have GPT, and here is the win rate against the supervised fine-tuning model. As you can see, when you use just a base model, the winning rate is very small. And when you use prompted GPT, that means like it's a form of GPT that has been given some prompts. It just improves a bit. When you use a supervised model, like supervised fine-tuned model, it's improved. But when you use a model that has been, like say, RL model, like the reinforcement learning model, and there they've specified like they use the PPO, like the winning rate increases. So actually, the issue with reinforcement learning is still like a research problem. So they are still trying to understand more if it fits like, or if it's going to help us create AI systems that aligns to our goals. So the essence with reinforcement learning from human feedback is to create models which align with human goals and to solve the alignment problem. So I think I talked about alignment problem somewhere. So that's it. And actually currently there is reinforcement learning from AI feedback. So what it happens, you have another AI model, and then you generate responses from another. Let's say I have a model A, and then I generate responses. Then I use another model to rank the responses. Like that's reinforcement learning from AI. That's also another concept you can try to explore it. So to finalize these talks, I'm going to talk about all the issues in this presentation, but it's a very, very comprehensive presentation. I recommend you to go and pass through it. There is a YouTube video about this presentation, so you can check a video and you can have this presentation. And I'm not going to continue with it, but I'm going to finish with one thing, and that is the concept of reinforcement learning. So I've been mentioning reinforcement learning. So what is it and why is it helping us? So reinforcement learning is one among the types of machine learning, I can say. So Steve in the morning told us about supervised, unsupervised, semi-supervised, but also we have self-supervised currently, and then there is reinforcement learning. So reinforcement learning, it just tries to mimic how animals or human being learns from the environment specifically. And it treats like let's say model as an agent that has to navigate and learn in specific environment. And there are mainly specific 4 attributes when you are talking about reinforcement learning. So the first thing is agent, and you can consider me as an agent. And then the second thing, you have environment or setting. So this is my setting. So I'm going to learn within the settings which I am. And then you're going to have like a state, you can say, I'm in what is state now? And what if I do a certain action? My state is going to change to another state, or what is going to happen? And then there is action actually. So action is going to contribute to the change of state in some ways. Also, we have police. Police is what is like the one who is training me wants me to follow that specific policy. So I'll give an example of reinforcement learning like in real life. So for instance, I have a kid, and that kid is learning to work, like to move from one point to another point. And because he doesn't know any law of nature, like for instance, the Newton's last law of like the third law of motion, like the action equal to reaction, is going to face some consequences because he doesn't know anything. And let's say he tries to move a leg and then he falls down, he's going to get the reaction back and he's going to feel pain. So from that pain, he's going to learn something like, hey, I need to make sure I don't fall because I'm going to feel pain. So we are reinforcing him to learn something from his own actions. And for instance, he manages to move from point A to point B, like I'm here and he's there. And then when he tries to come, maybe I start clapping for him. He's going to feel like, oh, like I'm being either rewarded because of what I'm doing. So you're going to make sure he reaches at the point where I am. So let's say when he reaches there and I give him a gift, let's say, or I clap for him, like I'm giving him reward, like, hey, you have done something good. And that's going to encourage him to continue doing that action, knowing that that is the best thing to do. But when maybe he does wrong, then I give a negative reward. That's what the reward that was being given when he falls down. That's a negative reward. It's going to maximize the chances of him falling down and trying to maximize the chances of him reaching a certain point without falling down. So that's a very simple concept of reinforcement learning. Welcome. That's a very simple concept of reinforcement learning. So I have a presentation here. I'm going to share something here. I don't know if let me check here. Did I share it? Let me check here. Sorry, I'm going to finalize in 5 minutes, and then we're going for the next session from Yusuf. Yeah, thank you. Let me do something here. Yes, kuna swali? Tunaweza kuwa tunaendelea kuuliza maswali pia wakati nakuja kumalizia. Karibu. Ndio. Ni share link au mmepata? Okay. Kuna mtu ka share. Okay. Okay, thank you. Ndio. Ndio. Ndio, zinakuwa tokenized differently. Ndio. So why? Yeah, so the thing is, because as far as I know, because they haven't exposed any further information about what currently what kind of tokenizer are they using. What I know, the bit pair tokenizer actually works. Let me try to remember. It works like this. So you have a statement like this one. Thank you. So let me find another statement here. I think I'm going to get one. Yeah. So for instance, that statement, welcome to a gathering. So what it does is it starts by breaking the words like it's like you considering the space. But then when you do by considering spacing, you're going to recognize that gathering is not like it's not a single word, like it's a combination of some words. So there is gather and I and G, right? So it's going to break down again. So you have gather, and then it's going to add some symbols there. And that's the symbol, specifically the hash symbols. So it's going to add 3 hash symbols, meaning that this word is gather, but it was like it was combined with other alphabets, I can say. So you have gather with the indicator like this is like it's a piece of word from a certain word, and then you're going to have ing. So the concept is when you start to write like the word either in reverse order or in a different order, it's going to treat it in different way, regardless of the meaning. Like you will find that the meaning is still the same, but the way they're being treated is different. And that's why when you, let's say you generate a response from ChatGPT, when you retry, you get another different response with the same meaning. So it's just the concept like that. I don't have very much technical details about it, but it works like that. Like it's like the way the tokenizer works different from different order of words or different order of like arrangement of sentences or words. So that's why we had a conversation previous, I think back in the days with Isaac, we was trying to think like, that's why maybe we find it is very difficult for this model to perform well in Swahili, maybe because those people, when they were creating tokenizers, they wasn't thinking in Swahili, like they were creating a tokenizer for their specific language, but we are using the same tokenizers to deal with language, I mean our language, for instance, Swahili. Possibly, maybe we might need another different kind of tokenizer that fits the structure of our language. So that's my view. I don't know if they are right or wrong, but we can go with them and try to think in those perspectives. But I think I tried to respond to that, but we have a very big chance of still exploring and understanding what actually happens on the scene. Though most of the technical details currently are not open, so we never know currently if they've improved the tokenizer or they did something different. It's very hard to understand. I think I tried to respond to that. Thank you so much. Yeah, so I was talking about the presentation I'm having here. Okay. So I'm going to share a story. Last year I was invited at Mbeya University of Science and Technology, and actually I wasn't having any presentation. I was in a bus and I didn't prepare anything. So what I did, I searched for an AI app that I can create a presentation, and then I found this gamma.app. Then I write there, they told me to talk about AI-powered innovation. So I write the title, and then I got the full presentation. That's what I presented. So for those students who were there during that presentation, actually there are 3 here. That presentation was AI generated. I did the same today. So I tried to generate this simple presentation here from that specific application. You can see here made with Gamma. So you can go there and put your title, and then you get presentation like this one. Yeah, so introduction to reinforcement learning. by Zephania Ruben. Edited 5 hours ago, so you can see. But I wanted to, I have already explained the concept of reinforcement learning, right? And here the importance of human feedback in reinforcement learning. So why do we need human feedback? And when you say human feedback, that means we had other different ways of feedbacking the agent in reinforcement learning. And those were the natural, like the classical ways. Like you have an agent or a model, you are trying to train it using reinforcement learning. So you're going to use, let's say, maybe rewards like either if it does well, you increase a certain number. Maybe you have a number maybe set to 0. So when it does well, you increase the number maybe to 1. And then when it does bad, you decrease the number maybe to 0. So you count like how many points going to do correct or to do what you want. So it's like you do pointing, like you do increase the points. But with human feedback, it helps to guide the agent exploration. Like human feedback can help the reinforcement learning agent explore more promising actions and avoid costly mistake during learning process. So as I said, when they create those specific data sets, they actually hire people and they pay them and they give them a contract that makes sure what they are giving as a feedback is having a high chance of being the correct thing. And there is a story I was reading last week about LinkedIn, who have here LinkedIn like voice something like I don't know what they call it, like something voice in AI, like I don't know those badges, I remember them, but kuna badges fulani ambazo LinkedIn walianzisha, like you find like there is a question and then they prompt you to respond to it. Like maybe you as an expert, can you respond to this question? So someone like they have stopped that thing. I don't know. I'm not sure because I was reading an article, so I didn't do so much exploration. It's like they were trying to gather data from experts about different topics. So you may find like you're being prompted to respond to a certain article or to comment to a certain article. It's like they were trying to get more data from experts on different specific topics. So that means when you have human feedback and maybe we really trust that specific human, we are sure like we are going to have the model that actually makes minimum mistakes. As you can compare the first version of GPT maybe to the current version, it's very good compared to that. Aligning agent behaviors. So human impulse ensures the agent learned behaviors are aligned with human values and preferences. That's what we say. And enhancing interpretability. So we shared some days, like it's very hard to interpret like how these models work. But with human feedback, because you know what actually you fed is some kind, makes it possible to either to interpret what actually why a certain model responded in a specific way because of the data you fed. And here there is a traditional reinforcement learning and human feedback. So traditional learns solely from environment rewards, which may not always align with human preference, can be prone to unintended or even harmful behaviors if the reward function is not certainly designed. So if you didn't design a reward function in a good way, you have a chance of creating an agent which is not actually doing or aligned to a goal you intended it to do. Human feedback incorporates direct human guidance and evaluation, ensuring the agent's action are aligned with human values, allows for more and contextual feedback that can shape the agent's behavior in complex scenarios. So types of human feedback. So we have reward feedback, explicit reward, open provided by human to signal the agent performance. So it's like you give direct, like it's like when you are giving like a thumb up or a thumb down on a certain response, like this is good, this is not good. That's kind of or verbal feedback, natural language instruction. So you give it instruction like, hey, do this and do that, like that. Or demonstration, you can give it examples. Like instead of writing only instructions, you give it examples of what is supposed to do. For instance, you can think of it sometimes for those who are doing RAG, sometimes you write those templates or like the system prompts where you give it example of how it's supposed to respond. You can think of it as like you are doing demonstration, but also preference feedback. So human expressing their preferences. So you express yourself like if I X, Y, Z, or ranking the agent's action or output. I talked about the ranking thing. So that's the other part. So to implement reinforcement learning, we're not going to dive into technical details of implementation, but you do reward the engineering, design a reward function that accurately captures human feedback and value, correct data, feedback integration. That means, as you can see, currently when you use even ChatGPT, they have that feedback integration, like you can provide direct feedback of the responses if we are satisfied or not. Yeah, and that's the end of this session. I welcome some few questions, then I'll be ending to welcome my brother Joseph to continue. Thank you. Yeah, so from online, it's time for questions. Okay, so if there is no questions, we can welcome, before we welcome Yusuf, we have to do one activity because we are sleeping. Yeah, so welcome him.
What kind of reinforcement learning used by Anthropic?
Yeah, so it's very difficult to tell specifically because, as I said, these people are doing things now in closed rooms, but we might assume maybe between these or the combination, like someone can do preference feedbacking, demonstration feedbacking, how many reinforcement learning or verbal feedback. It can be a combination of all of them or demonstration. Maybe it depends which one works well specifically in your case, but to be specific to your response, I don't know. I haven't researched for that to know actually what the exactly kind of reinforcement learning they're using. But we may have time to explore if they have disclosed those information. Because, for instance, I'm coming to you, brother. For instance, for OpenAI O1, I don't know if anyone knows actually how the reasoning thing works. So people tried to anticipate from the papers which has been released recently about reasoning, but no one is sure. Like, so this is what OpenAI O1 or the Strawberry model actually does. So it's still having some access to knowledge, some specific knowledge, but it's very difficult to get the knowledge from the source itself. As before ChatGPT, Google were open sourcing everything. Like currently we have access to Transformer, everything and all that, but after it turned to a business, a very competitive business, then people stopped it to share because they want to make money out of it. So welcome, brother Ernest, sorry, yeah.
So, I'm not sure if I've missed some details or I'm just not AI technically well.
Yeah.
But we have a project where we're exploring how to use AI in our compliance apps, and one of them is some sort of a chatbot. I put in simple terms, but basically at any time in business owner to just ask a question about a certain insight of their data, sales, their budgets, their taxes, or whatever. Now, I think we do use RAG in that sense, and I think you mentioned there that there's a way you can input the system prompt.
Yeah, the system prompt, yeah. Yeah.
So is it safe to say that whatever model we're using is already doing this, or there is a way that we can use, those four there to try and give it feedback whenever, how does it work when you're exactly hands on that? Because I think it's a bit abstract. So like if we can go like.
Okay. Thank you so much. Thank you so much.
Yeah,
Yeah, I'll try to respond. Then we'll give time to Yusuf. Then we'll have more conversation, I think. So as far as I know, it's possible to explicitly do reinforcement learning from my feedback with RAG applications is possible. Then to your case, that means you have to have data actually. So you need to start creating data on what you want to reinforce the model to do. Otherwise, you can opt to use system prompt. And you said you asked like this model have their system prompt. Actually, someone tried to some months back tried to hack and to like he exposed the system prompt of a certain model. I don't remember. So they have their system prompt already, but when you are using it, you can create also a system prompting, and that is based on that specific application. So if you feel like the system prompt you have created works perfect on what you want to do, you can end up there. But you can also incorporate, you can do reinforcement learning on that specific model. I don't know if you need too much resources, but as we have seen, there is not much of resources you need. The issue comes to curating data. And for the case of codes and how to do that, codes are there actually. The issue comes, as Onani was sharing yesterday, on how to create data and to format them so that you can use them. Like sometimes you find like those, like that knowledge is very hidden, like you can't get it easier, like other kind of knowledge you need. So that is my perspective on that, but we can explore more and see how that can be done. Yeah, thank you so much. Any other question? Yeah, so we have 1 minute to do one activity, and then I will welcome Brother Yusuf to continue. And yeah, so from online, if there's no question, we're going to have like an activity for like 2 minutes, and then we're going to continue. Yeah. Can you transfer watches in the send you online? Send you okay, sorry. Can you stand up a bit kufanya jambo hapo? Yeah. So, nitakuwa na mention matunda. Unajua matunda? Sasa hizo meza, hebu tungesogea hivi, sogea pembeni, tuje pembeni ya, tuje pembeni ya kuja pembeni. Yeah. Sasa tunafanya hivi. Nafanya hivi, si ndio? Kuna mtu anasema nitaje matunda kwa Kiswahili. Yeah. When I say apple, we jump forward, right? Five. Apple we go forward. Si ndio? Pineapple we go back. Si ndio? Kwa mfano nikasema apple tutaenda mbele, si ndio? Nikisema pineapple tutarudi nyuma. Si ndio? Sasa hapo mnaona spidi ndogo, lakini mtashangaa yenyewe mtajua nini. Kwa hiyo apple and si ndio? Alafu nikisema orange una turn right. Kwa hiyo apple, pineapple, orange. Sawa? Bado moja ya mwisho. Na mimi nitakumbuka kweli, mtanikumbusha sana. Kwa hiyo we have apple, we have pineapple, we have orange. Ndio. Kuna nyingine watermelon. Sasa watermelon kwa sababu ni ndefu, banana. Kwa hiyo sasa nabaki matunda mawili hayo. Ni kwa sababu ndio matunda nayo yajua mengine sijui. Kwa hiyo tuna watermelon, sio? Sasa watermelon kwenye state yote ile tutakayokuwa tunageuka. Sawa? Mungu atusaidie. Sawa, alafu banana tunageuka kwenye state yote tutakayokuwa. Nikisema banana, unaangalia left ni wapi ndio unapoenda. Sawa? Narudia ya mwisho kabisa. Apple, pineapple, ndio? Alafu huku nilisema nini? Orange. Alafu huku nini? Banana. Alafu hivi turn, like turn around, au nini wanaita Kiingereza kingine? About turn. Hapo tunamixia watermelon ndio tunafanya hivyo, si ndio? So let's give it a try. Apple, pineapple, banana. Hapo tuko vizuri. Haturudi. Sasa tunapiga moja, kama hakuna aliyekosea tunaendelea na sisi inayofuata. Haya. Banana. Aliyetuambia banana mwenyewe. Itabeba nayo ile chakula. Sasa hivi tuzingatie mtu. Kisha tutakuwa tunamcheka. Yaani tukuzingatia kitu tutakuwa tunacheka. Haya. Pineapple. Apple. Pineapple. Watermelon. Banana. Sawa, mimi nilikuwa hivi, kuto banana, si ndio? Haya, tunaendelea. Apple. Tunamtaeleka anataka kwenda left, anataka kurudi. Pineapple. Apple. Orange. Banana. Yeah, so very soon it's time for the attention. I say, hatari sana. Yeah, so next presentation is from our brother Yusuf. So let me see here. Yeah. So let me put it here.
See if it opens before you share.
Yeah, don't worry.
Yes, kama vile inafunguka vibaya.
PDF iko file.
You prefer PDF?
No, like kama
kwenye simu yangu inaonekana hivi.
Okay, basi ngoja tujaribu hivi.
Jaribu kwenye PC yako au tuisha.
Fanya hivi.
Hi. Habari za jioni. Okay. It opens well. Good to know.
Yeah. Okay. Watu banana naenda huku kwenye mango. Naambia orange anaenda kwenye banana. Yeah. Yeah. Yeah, we have.
Okay.
Kwa sawa. Nipe PDF tu ili nani save his name. Let's try this one again. Yeah. Nitumia WhatsApp.
Send you a second one.
No, okay, don't worry.
Go on to. Let's see. Okay, wakati naweka sawa. So my name is Nico. I hope online you can hear me.
Nadhani utakuja hapa ili wakusikie vizuri. Yeah.
I'm a computer engineer. I'm currently working Liquid, and what I do is lead the AI business solutions of the company, irrespective of industry.
Sorry, we cannot hear the presenter clearly.
Yeah, so he's going to be audible. We are trying to set up the slide. Yeah, so
Okay.
when he starts going to be at the podium and we are going to hear him well.
Yes. So
Okay.
So maybe I'll talk while I'm here. You can hear. Hi, online.
Hi.
So what I do is I work with customers as they come, see what AI could do for their businesses. So it's kind of an adventure because I get to see different use cases day to day. But being an architect, so I spend my time improving the point of
Sorry, Yusuf. Can we have a PDF?
Let me send you
Yeah.
a PDF.
I see it.
Sorry.
Oh yeah. Perfect. Okay, it's okay now. It's very, very visible.
Okay. So we're gonna use PDF, right?
Yeah. There was some.
There's some images. Okay.
That's very bad.
So how many minutes should I do?
I think we can use like 30, 35.
Okay.
It's very perfect.
Okay. Hi again. So I'm going to present help. Zafania. Help. Oh, oops. Sorry. Actually, I think it should work. So I was saying I work with different use cases. They come, I sit, assess their infrastructure, the tech stack, their data, where is it? How is it structured? Is it ready? What are the internal processes? Because with AI, it's just not because you have data, you can have one. It depends also on what you want to get. The greatest kwa hapa Tanzania, the most challenge is ile maturity level. So you find someone needs first a digital solution before even an AI-based solution. So you're like, okay, why don't you now have this on cloud or have your data well organized, ready? Put your processes clear. So you might find a solution. Tatizo linaeleweka, data zipo, lakini tu internally, the way the leadership communicate or processes the approval, the chochote, they are not clear. So you cannot create a solution that does not reflect internally. And if internally kuna tatizo, so it's an adventure. just to say for who mpo hapa and online, I have an assumption. There's a difference in, I was informed, there's a difference in skill-based. So I know there are those who are now ndo tunaanza. Kuna ambao ni watabe tayari, na kuna wale ambao kwa kweli ni watabe sana. So we have beginners, intermediate, and pros. But again, in this field, there are many careers. So there are those who they are skilled very well to do the deep stuff when it comes to hands-on. They write code, they do that. Again, it goes more. AI brings more of careers than just writing code and becoming a machine learning engineer. So it takes to many aspects. So you can see as we go, where do you fit? And because it's more tricky, like it's more deeper, you really need to do where you think you can scale, you can love doing, right? And yeah, so I'm going to speak about foundation of modality, and I'll use 30 minutes. I'm going to present in a very storytelling way. Ili msichoke. It's going to be very short. Ili iwe foundation kweli. So I'll really skip the detailed techie stuffs, but I expect at the end of the presentation, you know where to start when you're dealing with multimodality. Informations are online, so knowing that you're here is not that you could not Google or learn, but it's where do we start, because it's chaotic. So one of the goals of these sessions that we are having is to say you can start here and you can scale to your own speed that you need to learn. So, okay, so my outline will be in this mode. I'll assess, we'll be discussing. It will be very interactive, right? So I want your minds with me because it's going to be very short. I'm going to have an AI overview. I want to know what you know because I already know you've been learning, so as we can have some context. So we have an AI overview. What is modality? What are the types of modality? Multimodality, and we can check on architectures and what is done, right? AI has been changing. The definition of AI has been changing. What is AI today may not be AI next 5 years. So there are many contexts. AI can be a system, AI can be an agent, AI can be typical algorithms, MySabu. So AI is defined in different contexts, depending on what we are discussing. So are the terms in my presentation. So it's what you've been learning. Today you're learning supervised learning, but in a certain context. The next day you find the same things, but they're used very differently. So always to maintain context and context. So just a quick one. Ni very interactive. Mtanisame, I know ni watu wazima. So I'll be saying flani what. So in a quick way, AI ni nini? From what you've been learning, what's AI to you?
Me, like AI is not like a tool.
What
brings the best out of human life? A reasoning tool.
A reasoning tool? Yeah.
So, like for now, AI cannot completely act like a human, but helps to bring what's best for the human.
Perfect. From his definition, can we have a more technical add-on on his definition when we say what's AI? Quickly, you can now open GPTs, read for me, it's okay. Okay, so that's how my discussion is gonna be. So next questions, I hope we engage. It's always been trying to map what humans do, right? We're not there to say machines or systems can think, but we know right now we can mimic. So can we all try and breathe? Just breathe in. and try to see, okay, breathe out. Okay, can you smell something? Like, can you hear? Can you smell? Okay, can you touch something, right? You can touch, right? Can you feel something? Speaking about feelings, can you feel something? So we want, when we create any AI thing, the thing that you're saying, something that mimics what humans could do at the best, we need that to have those feelings. Like the ability to not only analyze one thing, but many things. The more many things it can analyze, the better it can bring results. So modality, by definition, is a particular mode in which something exists. So from human terms, the sense of touch, of taste, of smell, of sight, and hearing is what machines have been trained for: computer vision, audio, text-to-speech, natural language processing, the things that we've been learning. Those are what humans could do. In artificial intelligence, when we are speaking about modality, we are speaking about the type of input and output data an AI system can translate or interpret. So modality is something any that we have been learning, be the things that we have learned in large language models, be the things that we've learned in training, whatever model you are trying to create. The input data and output data, that's called modality. And there are types of modality. They are visual. So visual kind, so here we are speaking about images and videos. That's one type of modality. We are speaking about the data type, right? So sound. So we are speaking about waves. Texture. So we are speaking about text, right? There's where you get GPTs. Sound, you get other solutions like Siri. So you can say, hello. So Siri deals with one modality. I know we are advancing, right? But initially we would say Siri deals with one modality. That's only audio kind of input. And outputs what? Audio. So we have visuals, we have solutions like YOLO that would fragment pictures into frames to tell you what it is and give you back feedback. We have texture like GPTs that we are all friendly to them. And we have tactile, that's more of sensory. So these are different modalities that can go to an AI system and get an input. And for each modality, you can have a solution specific to get details out of it. Kwa hiyo tukisema GPT nikiandika text, sina translate. Alafu inaletea text. Ile old version ya kwanza, achana sasa hivi tupofikia. Kwa hiyo nimeweka text, imechakata, imerudishia text. We would say initially, a GPT is dealing with only textual inputs. So it's like a one modality kind of a thing. Same to sound. Na kila input inakuwa ina architecture yake or models that would favor. The neural networks, you would see many techniques humo ndani, we would see in a discussion, knowing that we have already touched base on some since yesterday. So modality is how something exists, and in AI, it's about data. And I am a data engineer by profession, so I love data. In fact, data is what we call a fuel for any AI solution. So when we say multimodality, we are speaking about having computer systems, intelligent systems that do not only work on one type of input of data, but many inputs of data and give you many output responses, right? It's like being close to humans. I can see, that's vision for me. That's one modality for me. But my brain could also hear, could also command what I speak, command what I do aggressively, or feel. So a multimodality in AI is having a system that can have many streams of input to add more context to the feedback that it gives back. So to LLMs, we are speaking about text, image, speech recognition with visual cues, video summarization. You upload a video. It does not only say what it sees, but it can also say what audio is speaking about and give you a summary of it. Multimodality. It's very important to see what is happening when we speak about multimodality in AI. We're speaking about one close step to having machines very close mimicking. We saw Elon Musk with humanoids. So after we had embraced the ability of machines to channel many inputs of different sources and give feedback, we are now confident to say we can have humanoids because now they can see, they can hear, they can touch. You see what is happening? Now you can see what the future happens with multimodality. At first, the breakthrough was just unimodality. Some say singular modality. Only one type of data, translate and work on it, predict and do all those decision makings. But now we have more. So I hope it's clear when we are speaking about multimodality. So yeah, in the future, we could see AI systems seamlessly switch from communicating to text, to voice, to images, and performing complex tasks because it's a real-time assistance in dynamic situations. So I would give an example. Before Mika is one of the solutions we have. It's just typical texture. So you have one single data type coming in. You have an AI model that translates and works on that data for decision making. And then you have very narrowed results because you only have one narrowed way of input that you have. But with multimodality, we see ChatGPT, Cloud, Gemini, DAL, and many that you can prompt the system, whether by text, by email, by chats, and it has that model that could comprehend all those inputs and give you a variety of outcomes. That's multimodality. So I'll be going in very simple terms, and then we'll be repeating the same things, but I'll be adding in more terms, and then more terms, and then I'll give one assignment at the end. So if you would see this graph, this picture, I hope it tells more. You had some say unimodal, some say single modal AI models, and you had one input. You have that other input. So to just add more light, you have many inputs. You have a wide range of results. So let us break down. And this now is you to listen because I did not put many pictures here. I did not use gamma. I thought because I'll be high in a high level, I would leave, you'll have these documents just to guide. I prepared a presentation that if you listen and then you use it, you'd now go deeper by your own ends. So let's think before multimodality, right? You would have maybe a visual concern, a challenge that deals with images. So we would say, I want to create a system that can classify my images. So you would say, if that's my case, I need to have an AI model. Sasa mimi ni muumini wa kutokuassume. Nikisema model tunaelewana ndugu zangu. I don't want to assume. Dada, you've been smiling. What is a model in AI, if I would say? Don't define just what you get it. Anyhow. Perfect. So, umepatia yani. So a tool, so AI model, a model is a tool that is trained with data, but not only trained with data, it should be able to react to new information so it can make decisions. That's a model. an AI model architecture is like a map of that tool that clearly tells how data comes in, how is it processed, how decisions have been made, what layers will it go through, and how outcomes will come. So this table tells in a unimodality, if you wanted to do with visual issues, I would say I want maybe to deal with my picture, I want to classify it. I would go and pick a tool. Some would say a program. Some would say algorithms, functions, but AI model, meaning something that was already trained, or we are speaking now as developers in a sense, that was already trained to do a specific kind of task and help you do the decision making. So I would say for this, if I want to classify, maybe I would use convolutions neural networks. So this is one of a tool, a technique. It's an AI model that tells you what it could do in terms of results. So you would see in visuals, in sound, in texture, and tactile, kwa kila unimodel ni kwamba nitafanyeje data ikija, naichakataje, na natoa taarifa. That is in a single view. Tunapokuja kusema ni multimodal, tunakuwa sasa na mfumo. This is how multimodal works. Tunakuwa na mfumo ambao unapokea, tuseme input 1 ni picha, input 2 ni text, input maybe 3 or more labda ni something else. Maybe it's a video, I would say. Videos and pictures are the same. It will be sound. So I'm having a system that before it would just be one task, a model, an output. But now I have it together. It's a multi-model AI system. It has a number of different inputs. And then hatua ya kwanza ilivyotengenezwa sasa multimodal ni kwamba I get that input, I process that input with a relevant AI model first. And then the third unit, I fuse different outputs from each model respectively to that input to make one representation of a unified input. I'm breaking it down again. Nina video imeingia, tunarudi kwenye ile table ya mwanzoni. Video imeingia, nina sauti yake, si ndio hivyo? Alafu nina caption. Let's take that case. Nataka ni deal na an AI system ambayo inaweza ikanalize video, ikajua sauti, na ikanipa captions, right? Kwa hiyo nina input na modality ngapi? 3. So I have 3 modalities. I would say, kwa video ambayo inakuja, maybe I would need to just classify. Is this a musical thing? Whatever it is I want to classify. So, ile video niki-upload na caption yake, inaingia kwenye multimodal system. Multimodal system inaenda kufanya, inasema hapa kuna inputs ngapi? You see, there are 3 modalities. So, it takes the video, we say maybe the image, our input 1. It takes it maybe to one of the AI model. An AI model would say maybe it's hiyo tuseme ndio tumeichagua, naona imekaa hapo mbele, our CNN, convolution neural network. Kwa wale ambao sasa tuko tunajifunza kwa awali, hii in briefly yenyewe inaeleza picha ikiingia inaivunja kwa layers into small granular fragments, inachakata ku make sense. What is this segment doing? Alafu inatoa output. So it comes in, it enters to a relevant AI model, a tool that our colleague said, a tool that does what we want to do. Ichakata, inatoa feedback. Ile feedback inasubiri. Inasikiliza sound. Sound hiyo inasikiliza. So kwenye sounds kuna waves, right? Kuna high, kuna lows, kuna pitch, kuna timestamps. Inachakata audio tu peke yake. That would be on the second, for maybe speech recognition. So it use maybe one of the models, recurrent neural networks. Itaichakata, itaweka pembeni. Itachukua text. Maybe we use, because text has been so fast, you use a GPT. It will train, itatoa. Kwa hiyo, the first step, an input comes, it goes to a specific, unique AI model. That model would translate. Hizo input tatu zikitoka, kuna kitu kinaitwa fusion models. So fusion models, just the same techniques, but now it takes all these three presentations. Like we know, like AI is typical statistical mathematical presentation of a problem. So we would say an AI model is a presentation of a problem, a mathematical presentation of a problem and how we could get solved around it. That's another way you could define an AI model. Now, ikiingia kwenye fusion models, they have techniques. So with fusion, kwenye graph, kwenye block diagram, fusion inataka intention yake ni kutengeneza one output, representation ya zile input zote. Kwamba tatizo letu hili lote liliouploadiwa, this is how it can be presented and these are the details. Fusion. So there are techniques, if you will, as we learn, kuna attention mechanisms. So attention is where it checks what is important. Like mtu ameongea, we cannot like take all the words. We take maybe anasema introduction. My name is blah, 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 blah. Maneno mengi, I'm from the high mountains of Kilimanjaro. Then he just says, this guy is Mel, high mountain Kilimanjaro. Maybe this is the northern of, mengine in a drop. So it's called self-attention. It only picks what matters. That's the technique of fusion. So because there are a lot of inputs from the first models, it just wants to take what is important. So there are techniques like that. Cross-attention is used to align and integrate information from different modalities. So for example, I have uploaded the video, right? So nimevunja picha, lakini sound na text natakiwa captions ziendane. Kwa hiyo lazima ifanye cross attention na kuangalia kama nimechukua haya maneno ya msingi, what are the cross checking attention details relevant with pictures, ili vilete sense, what are the timestamps niweke sawa. So kwenye fusion models is where we see how we match those. So there are many techniques we would learn, but because foundations, we could just end there. So these are techniques just work on bringing things together as how complex it would come. Back to your diagram, after the fusion model. So task ya fusion model ni moja, could represent all the outputs from the first uni models into one presentation. How would you present the video with the caption you've uploaded into one thing? Ikisha present, zinakuja sa classification networks. Classification networks, they are just AI models again. But here we call them classification networks in a sense of context. Like now, they are not only going now to do analytics of the inputs, but they're taking this unified to make decision. So here we are going to get again the same, their techniques, their classification techniques, the same. So if it's a layer that deals with image and video recognition, it will do its thing. If it's about the data and time series and natural language is textual, it will do its thing. If there are many layers, so it's the same techniques, but now in the context of now bringing sense and giving you feedback for your output. So that's how multimodality works. I'm left with 2 slides. So I'm going to start bottom down. A multimodality in AI is having many inputs, different data types, and different outcomes. It's how we have systems that can analyze more than one type of data type. How is it built? It's built with different layers. So you would see there are different layers, but this one is more of an ideal one. You have your inputs, the data you give. every data that comes in is broken down into different specific tasks where it will go to a specific AI model. Those inputs will be joined, integrated together to represent the whole input as a one problem statement, I would say. And then you have classification models where now they will come and make decisions. That is multimodality in AI. This ability in our AI systems add a lot of advantages. To name a few, it adds more context. So instead of just saying that's a tree or that's a video someone talking, you would say, what is they talking? What are they talking? What are they feeling? We can do semantic analytics. We can really have a good way of how our systems, be it a software, a tool, be it an algorithm, or a humanoid, be it something that would use and interact in decision makings. That's multimodality. But it adds more. We get more complexity concerns that are solved because we can have systems that can analyze what is happening. So there are examples I'll assign as we close, but I'll say there's a challenge. While we advance into having AI systems having more inputs and outputs, there are challenges. There are challenges on how, have you seen how we learned about just shortly about fusion? Unakuwa na inputs nyingi zimechakatwa afu unaziweka kama kitu kimoja. How do you represent input ya sauti ambayo imechakatwa mathematically, input ya picha au video na maneno to one problem? So there's always a challenge of how that is represented. And the danger is if you're not keen in developing, you might end up having a lot of noises, a lot of misleadings. Kwa sababu mfano mtu anaongea alafu na speech sinatoka sauti. What if we mismatch a word and the action ambayo mtu anaongea? And what if maneno akakosewa? So you find those challenges in representing that one's problem statement of different inputs for our systems. So you may also miss data, you may have structural issues, format issues. So these are the challenges that comes with multimodality when you're creating. Translation, so this is converting one data to another data type. So say you would love maybe to convert text to video. So you see there will be a challenge how you would translate. So they're not perfect. It goes with accuracy. So there are the challenges when we are speaking to multimodality. Alignment. So I spoke on fusion. How do you align these different inputs in a fusion output? In a sense, they are concurrently relevant and it's inaendana has mismatch. But the same to fusion, like it makes more complex in decision making and prediction, because if you have different noise levels, pengine umeupload kitu ambacho video is good, audio is very poor, or text is misleading, some things like that. So when it comes to when you're merging these models, the modalities to make decisions, there's a challenge on how you deal with the fusion so as you can have an ideal or more optimum output. But also co-learning, training modalities together to improve mutual knowledge transfer. Poor co-learning can negatively impact training, but the things that we mitigate with different techniques. So that's for me to the presentation. Before I say what I would love everyone to do, it might be a takeaway for home or here, but I want it to be done here in just like 5 minutes. We can have many use cases now. We are now confident in a sense because of multimodality, we can have more productive use cases for businesses. Because it's important, whatever we learn, we see where we can use in real world, because stajua, and then how do we make money of what we know? That's why it should make money. It should bring sense. So you have hospitals where you have different analytics. You have your maybe radiology department. You have now you can analyze your pictures, your whatever you get from a radiology with the sounds of what the body could produce, with the diagnostics that the doctor has got from a lab. Kwa unakuwa na comprehensive output in a solution kuliko expensiveness ya kuwa na models pembeni ambazo sio kwenye mfumo mmoja, because initially you could process any input individually, but now again as you communicate, now we can have that in one system. See how that could do in a hospital. See how that could do in customer service. Mteja ana shida, place I work, we also do networks. Labda router yake imezima. Now hasemi tu router yangu imezima na ni sina internet, anaweza akapiga picha kifaa au akapiga details aka-upload, and my bot would say, would even advise based on this picture, maybe this is the loss of signal. Labda cable umeikunja. So you'd see how within having an AI system that is multimodal, we have different use cases that would help. Here in museum, tuko kwenye museum, you would see their cars, their history books, kuna vitu vingi. So you can enhance the photos that we have, enhance the cars for people to see online, but also in the same interact with natural language processing in a single system. Now you don't need to have different APIs to just calling feedback from different systems. You can have that in-house in one unit and do all these things that are there. So there are some examples. And where I'll say, I'll bring in questions and then say what I assign, and then we close and have a happy weekend. So we have like multimodal, different models, AI models that are multimodal. I've given a sample. For example, text to image generation, or we have Clip among many. Clip is an open AI multimodal. Available architecture is also drawn, which I'll need you to draw. So Clip does that. It does text to image. What they did, when training, they took a lot of photos, and then they details, captions from Wikipedia, try to train to relate. Now, you see how it works. Picture, wakazivunja, afu wakavunja text, wakaangalia zinaonana aje, yani zinalitije, mtu akisema kitu fulani caption ipi inaendana na picha ipi. And then wakatrain a lot of text, because in training imagery ilikuwa ni ngumu. There's a very limited ability to have enough photos, but you have billions of words. Kwa hiyo wakasema, what if now someone comes with a word and there's no picture? So with this model, you can now get words na picha ikaja ambayo hata haijawahi kuexist, because of the relation between pictures and text. So you would see for many, I've just kept different multimodals that are out there for us to go and see. So before I ask questions online and here, I would say my assignment would be, can we sketch here in the next 5 minutes what a clip, this, we can go online too and search the architecture of the clip multimodal that I've presented here. I said clip, C-L-I-P, is an abbreviation of words. So you would see what's long it is. But what I want you to do is go and see the architecture. Architecture, nimesema ni map. It's just a presentation of how data inaingia, itapita wapi, itatokaje. It does not go more to specifics. So everybody see online and here, go and see the architecture of this and sketch it on the paper. So I would say These two tables is one group. The rest of the two tables is one group. Ambacho nataka muingie online, muangalie hii model, mchole architecture, afu mshauriane kweli mnaona multimodality kwenye architecture. That's the only thing I want you to do. So thank you guys. Nikaribisha maswali. Online, I hope I was audible and I was quick, so I hope still mmeweza kugrasp. It was a high-level presentation of multimodal as foundations. And any questions? I'm open to shoot. Yes, brother.
Again, I'm not very much into the technical details of the
Yeah.
AI roundabouts, but how do we the fusion part? I have a thought that part because I have heard of vector databases.
Okay.
The vector embeddings and everything, the way we take something, you convert it to vectors.
Yeah.
Then you have this huge storage of vectors, and then whenever you have, for instance, in a RAG application, you just check what is in the vector, you make it, and then get the response. Is it the same way how we end up representing different models in one place? Is that one application of vector database, or how essentially can we get to have the same representation for different, like the word, say a cat in the text, and then the picture is also a cat. So is the cat, maybe using the vision model that of its own makes the vector, then eventually they're going to be the same as the one,
Okay, thank you. That's a nice one. Any other question? Okay, so to address
On our side, you don't have a question.
Okay, thank you.
Yeah, okay. Thank you very much.
Okay, so to address the question, so we have to get back to what an AI model is. So maybe that would be like one answer for all. Like in real sense, when you're speaking about AI, we are speaking about mathematics, right? So anything we write to these agents, to a computer, is a mathematical challenge. It's just a mathematical concern. In fact, it's not like they know you've said good morning. They just know this is a math. How do I make sense of this? So it's statistical, it's vectors, it's matrices involved. To present that problem, to get answers, and then we have a high-level presentation that makes sense. So that's where probability comes in, to see the correlation of the likelihood of what might be the answer based on what has been trained. So these systems, be it visual, be it a normal database, textual, structured, unstructured, be it any file format, in an AI model, it is broken down to a mathematical representation. And how that mathematical presentation is set with elements that see how the actual contents relate to each other mathematically. So it's a probability guess. There have never been an AI model that is 100% accurate at that basis. So maybe you'll tell me if I have addressed, in a sense, for a multimodal, assuming you've addressed a cat with a caption, text will go to a textual AI model, a GPT that will make sense and see how that relates to what is being trained on, and the prediction it would give the likelihood of what you've asked. Picture of the cat will go to an image AI model. It will be broken down and presented to the likelihood of what might be expected. A fusion model will understand what an AI image model has given, and an input from the text-based, and it will also work now to represent, to see how this input of the picture and output, how can I present it in a way if someone comes, they can understand that this is an image plus a text. Then a classification model comes, takes that mathematical challenge, goes to the intent of what's been prompted, and make prediction. So before it would be different layers, but now we can comprehend that and have one system that can do that, but in units specifically as they come. Kwa hiyo ni kama vile kuna udalali katikati, I would say. Ni kwamba mmoja anachukua, mmoja tena anachukua, mpaka intent. Ila ana breakdown ili awe accurate in that sense. Sijui nimeaddress. But it's all same approach, different techniques. Na ndio maana kuna zile ambazo zinafanya vizuri kwenye videos, kuna zile zinafanya vizuri kwenye audios, likelihood on the same. So I hope I've addressed this. Karibu.
Yes, hello? Hello?
Yes, yes, you have a question?
Yes, I have a question, Mr. Isaac. Thank you very much for the nice presentation. Actually, I have some few imagination on my head, actually.
Yes, I love
I have made one of the application in the internet, actually, which is saying, can you make a picture dance from a certain picture? And then once you select the picture of anybody, and then select a certain kind of music, it is dancing according to the tune of that particular music.
Yeah.
Is that a type of the multimodal AI which are you talking about? And another question.
Yes.
What is your views on the issue of forensic cybercrime? For instance, one presented to the court maybe a particular kind of evidence which require a picture, video. What is your views on the reality of what it is presented into the court, maybe for an evidence regarding to the technology of AI, which is now going very viral? Thank you.
Thank you. Very, very thoughtful questions. So I would shoot. Number one, for multimodality, as we learned, is about having different inputs, data types coming in and data types coming out in different forms. So if you have interacted in one system that can work with music, that can work with the text that you've said, you've uploaded a picture and you've said, make it dance. And then that is text and that is an image. It goes to a system and gives you a video with music and its lyrics. That's a multimodal solution because you've interacted with it with different data forms, the picture, the audio. You are getting audios and text and dances and movements. That's multimodality by definition. Number two, when it comes to forensics, when it comes to deep to what you've said and code, so there's something called deep fake. It's the ability to know what's a real thing and what is AI generated. So it's like reverse engineering, and here's Emai Stefania would come in because it's more deep to reinforced and stuff like that. There are special now professions for deep learning, for deep fake. For deep fake. So it's the ability to see what actual data that you have is from an original source and what is AI generated. So what happens in those codes is where you get professions break down the metadata of what has been given. So you know everything has a digital print. So it's a bit to say, this was shot on Tuesday last year, but it went through these platforms. These are the details that have missed. For example, with AI, we see more of encryptions. You uploaded a photo, there are more additions. So we would see different data sizes, changes, different metadata coming in. Okay, this guy was straight. Do really people in a normal way dance like that? What are the nuances? Because they're not perfect as humans. You would see it's a worst moving, but the eyes are stagnant. So there are metadata that engineers would say, oh, we could justify this is not correct. So they are there, but it will pose more challenges because of how perfect we get. We are not there yet, but there are challenges, but kama ni kitu tumekitengeneza, we'll be able to know. We will be able to know. So with right tools and right knowledge, yeah.
Okay, thank you very much, Isaac.
Thank you. So it's Yusuf.
Yes.
Yeah, it's Yusuf. Thank you. My brother, I cut you. Apologies. Terrible. Okay. I would say intent. What are the results you want to look? There are many ways to go about it. I'm a kind of an informal guy, so I'll pitch scenarios online. I'm getting close to the audience, so you might hear me from afar, but I'm still here.
Okay.
It depends on the use case, right? Ukienda mahakamani, a paralegal will tell you. So mahakamani kuna wanasheria, advocates, and wanasheria wale wanaotetea. But they have so-called paralegals. Paralegals ni wasaidizi ambao kitokea concern wanaenda kuangalia historia yote ya kesi ambazo zimetokea kwenye mahakama. Nini kilifanyika? Maamuzi gani yalifanyika? Like ile historia. Kwa hiyo kesi kama wewe kama developer or an AI kind of a solution expert, and you need to say, in that context, quickly, you don't need a multimodal solution at first. You would say, so I just need to work on the data, text, documented. So I'll just use a single model approach. Nita-analyze, nita-train model yangu, nitachukua techniques, so the AI models, the tools, ambazo tayari zina-exist, ni mathematical presentations ambazo zimeshatengenezwa kwamba ziko bora kwenye nini, right? Kwa hiyo kwa mfano wewe unaweza kusema I need maybe a GPT as a model, sababu yenyewe ina process data, ikiingia hivi ina relationship inatoa. Kwa hiyo you create a paralegal system badala sasa ya lawyer kuhitaji mtu wa kumfanyia msaidizi wa kufanya hizo, yeye anaingia kwenye system, ana upload kesi yake ambayo ni textual, inaingia kwenye model, inaangalia kesi zingine zilifanyikaje na knowledge base iliyopo, inampa majibu. See how you approach it. Lakini inaweza ikafika ikasema in the same scenario ukasema hata pia kuna audio zipo za judge mahakama inavyoendeshwa. I want to be able to analyze that in relationship with what is there. You're like, okay, I cannot create two systems for audio, speech recognition, and text itself. I need now a multimodal approach in creating my system, where not only I have trained with the information texture that is available, but now I can upload or speak to my model, and it can take my tone. Teneza kwa vizuri, baada ya kusema jaji alikuwa amekasirika, with more of voice details, you create a model, use models that would say, hii kesi iliamuliwa tu sio kwa namna hii, lakini jaji alikuwa amekasirika, amehuzunika. Why? You've got tonation. So, based on use case, what comes, what goes, you would always see what type of data am I gonna need? Is it a single data form I'll be working with? Do I will be working with different data forms? Na output unaotoka, je ni text? Pengine itataka graph kama gamma, presentation, so it's more visual. Those questions will tell you, okay, now I need a system that is multimodal, that it can analyze different inputs. So last question. So I would like thank you all. I know time has gone. But yeah, so this is how I would close. As we learn these concepts, strive to know what these things mean by definition, right? Ili uone uwezo wa kuscale hata pale ambapo Zefania hajatuongoza hapa kwenye maswala kadhaa. So if you know reinforced learning, what it does and which he has said, if you know large language models, by definition, unaweza ukaielezea bila nani, you can easily scale when new concepts pile up and pile up. But whatever you're learning, for it to be relevant, see the use cases like, brother, how you've asked, where now could I use it? And that's how you can easily scale at your own pace. So my assignment is now, because time has gone, is not specific for you to do here. But if you get time, find any AI model that is available open source online. Try to see its architecture, the visual representation of how it digests data coming in and coming out. Thank you, guys, and I hope we get to become AI minds in the next future. Thank you.
Thank you. Yeah. So that was a very, very insightful presentation from Yusuf. And actually, it was the last session for today. So we are going to finalize, and for online, I think we can end up here, and let's meet tomorrow at 9 a.m. We're going to start, and that's going to be the last day. So I really appreciate all the organizers, Madam Erika and the team, and others who have joined online from different places, from Zanzibar, Suza, from Morogoro, Sua, from UDOM. Thank you so much for being here. I know Chris with the team there at UDOM. Thank you so much for being part of this. And let's meet tomorrow. Thank you so much.
Hello, just one issue.
Yeah.
Okay, thank you very much for the very robust day. I really acknowledge and congratulate all presenters for the nice presentation, actually. But I have just one concern.
Yeah.
How can we have the all presentation so that we can continue learning in ourselves? Because some of us, we are very still beginners on these AI issues.
Yes.
And again, I saw in one of the presentation, there are terms in which is called AI community in Tanzania.
Yeah.
Is it possible for me to join to be a member of that community?
Yeah, so for the AI community, I think we have a representative here from AI community. So I'm going to call her here to just highlight in brief, because he talked about it yesterday, but I know it wasn't possible for you to join us yesterday, but there is
Yes, exactly.
information about it. And if anyone, the audience here wasn't available yesterday, we can have some information. So please, Grace, just highlight some few things about the community, and then we are going to close there, like 1 minute. Yeah.
Hi, everyone.
Yes, hi.
Okay, so with regards to the Tanzania AI community, it's a community of those who are passionate with AI. And for you to be able to join the community, if you just go to any browser and type Tanzania AI community, you will reach our website, or you can type www.ai.org.tz. And from the landing page, you're going to see a button that directs you to the Join Our Community Google form. So you can fill in your details, and after filling in the details and submitting it, there will be a link to a Telegram group. So feel free to join in. And we're also available in all social media platforms. So if you need any information, or if you want to reach out to us, see what's happening, you can reach out to us through our social media. Yep.
Thank you very much.
Karibu sana.
Asante.
Yeah, so I think that was nice, right? Yeah, so thank you so much, Gilbert. Thank you so much, Nelson Mandela team. Thank you so much, brother Ipiana. We're going to end here for today, and let's meet tomorrow for as it's the final day. So we're going to have some insightful keynotes too. And we are having people who have built some projects utilizing AI, so we can see the real application from the local builders. So thank you so much, and I wish you a nice moment.
Okay, thank you. Same to you.
Thank you very much.
Thank you.
Yeah.
So
And the team.
yeah, thank you so much.